Hi, good evening, everyone.
Sir, your voice is very low.
Okay, just a minute again. That's the same problem is happening. Okay, uh, just give me a minute. I'll check once. Is this better? Hello. Am I audible now?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yeah. Okay. Okay. 1 minute. Okay. So I think let's start. Uh, are you completed with week 7? Have you seen lectures, understood lectures? What is there and uh, everything about week
Yes,
7?
sir.
Is that
Seven
right?
is done. Yeah.
Yeah, so 7 is basically what is it's a classification technique, right? We have started to learn about another supervised learning technique, which is a classification. I think week 5, 6 we have completed uh, uh, our discussion on one of the supervised learning method, which is regression, and among that we have seen the linear regression. Week 6 we have seen the different or various types of linear regression. One is ridge regression and another is lasso, right? I think till
Lasso.
that part, till that part we are actually clear. Fine. uh, Now, in week 7, we studied classification. We studied about classification. Under that, we have seen one of the like basic method, which is k nearest neighbor. What was the issue with k nearest neighbor?
It is using the whole data, not learning the algo model.
Yeah, so every time you wanted to predict something about new test data point, you need to it will not learn any parameters. What you will have to do is you'll have to use all the data again for for the purpose of uh, predicting about the test data point, like whether what is the label of it, right? Uh, so that's again that was the issue with that. Then we have seen another method, which is decision tree, right? Have you seen the logistic regression as well? I think yes, right? Week 7. uh, Maybe you have
Not
not.
in week 7, sir.
No, okay, fine. Okay, maybe it will come later. Fine. So week 7, I think we learned about decision trees, right? So if you ask some finite number
In
of
the end,
questions,
it is, yeah, entropy and the in information gain is there.
yeah. So these are the techniques, right? So from there we can actually uh, be able to classify the uh, okay, by asking certain finite number of questions, we are able to classify that, and the the decisions will be based on what, the entropy and the information gain, right? So you find out the entropy at the root node, at each of the child nodes, and then uh, uh, eventually at the leaf node, right? And then you just find it out that whether asking that kind of question, is that the right kind of question to ask, right? If the information gain is positive, then the question asked is good, right? If not, then maybe, or if it is zero, then that might not be a good question to ask, right? Okay. So continuing our decision this week, we will be learning about another classification technique, which is what, naive Bayes method, right? So it will be a naive Bayes. So have you seen the lectures on week 8?
No, sir.
Not
Not
yet.
all, sir. Just 2 or 3.
Till now, only one or two we have gone through.
Fine. Okay. Let us start. Whatever, let's say you have seen, right? At least maybe first 1 or 2 lectures, I'll assume that you have seen, and at least if 2 are there, then I think that is fine. It's not like then we can actually continue our discussion, because you should understand what first is that uh, whether what sorry, this modeling is generative or discriminative, right? What do you mean by generative and what do you mean by uh, discriminative? We'll see that in a bit. So first of all, we'll try to understand that what kind of data we will be having in supervised learning setup. So in supervised learning, when we call supervised learning, generally, and in that also, if you have a classification type of data, then how does your data look like?
Discrete type of data.
What do you mean by discrete type of data? The features will not be a discrete features, right? Only labels can be discrete. Is that correct?
Labels will be discrete, right?
Features can be continuous, right? So
Continuous.
let's say you have x1, x2, x3 up to xn. What are these? These are the data points,
That's
right?
right. Data points.
And maybe each of xi can be in
D
yeah,
RD.
all right. And we have corresponding labels when we talk about supervised learning, right? So it is y1, y2, y3 up to yn. So this is your data set will look like. And what about yi? Each yi will belong to either it is
Zero
a
one.
0 1 class, or let's say,
Yeah.
Mhm.
Either 1 minus 1 or 0 1. 0
right?
1.
So it's kind of a generally we think of this as, let's say, -1 plus 1, which is a positive class and a negative class. You can write it as 0 or 1, that is fine. Now so we have seen the two techniques, right? Which is k nearest neighbor, and one another is decision tree technique, right? What we were doing at that time, uh, so let's say in k nearest neighbor, what do you do generally?
We calculate the distance of each and every data point
Mhm.
from that test data
Mhm.
and calculate on basis of that, okay,
Uh,
whether it
so,
will.
so let's say you have all the data points with you. What do you do is, given the data, right? Given, so whatever you already have the data and its labels, fine. But what you do is, based on the data set in the nearest, like let's say neighbors, right? Based on those neighbors, you try to uh, see that uh, whether that test data point, right, will have the positive class or the negative class
Negative.
or zero class. Is that correct? So
Yeah.
what you generally do is, based on whatever x you are having, right? And okay, another thing is, like, given the data, you try to predict something, or we try to model this kind of relationship, right? Let us say probability that y equals to 1, whether this label is equals to 1 given the data, right? And this probability will be equals to what? Let's say 1 in the case, uh, if like all things are in majority, and if it is equal to 0 if it is not. What does that mean? 1 and 0 class, right? This is the class,
The
right?
class indicates the class, positive class and negative class. 1 is the positive class, 0 is the negative class.
Basically it is not generally probability or calculating. It is kind of sure, but still you can say that based on the data points which are with you, based on that you are trying to predict what label the test data point will have, right? And every time you whatever the test data point will be there, you will calculate the distances and you will find it out. Fine, that is okay. So there are two types of models. I think we have seen in the lectures also. What are those two models? One is called generative models, and another is discriminative model.
Discretize, discriminate.
Discriminative. So what does that? What are the differences between discriminative and uh, generative models? Is, let's say, let it is like how you calculate the probability. It is that difference. So in generative models, the probability is calculated like we calculate the joint probability, right? I think we have studied all things about joint probability in stats too. So, what does that mean? Given a data and its corresponding label, right? What is the probability that this certain data point with this label will have some probability? You're understanding the point? We will try to understand through the example which is there in your lectures as well. But generative models are those models where what you do, you try to calculate the joint density, right? Fine, joint density between the this is we call as attributes or let's say features, right? Or you can say the data points, and here they are the corresponding labels. Okay, and in discriminative type of modeling, what you try to find out, you try to find out conditional probability, which is probability of what is the probability that this label is equal to 1 or 0 given the data points. So in discriminative model, you try to find out the conditional probability. Okay, is that okay? Till this part is fine?
There is no probability of y, na?
Yeah, that is true. No, so generally what you it's fine. I'm not saying that conditional probability of what. So basically it's conditional probability that or probability of y given x, right? You if you wanted to
Okay.
say it in the sentence, it will be like probability of y given x.
X,
Like the
yeah, it
conditional
is there.
probability of y, because that the condition is that I have seen the data x, and based on that data, what is the probability that it will take y or what will be the label of y?
Level of y, whether it will be 1 or 0. Yeah, 1 or -1, right?
Yes.
And
So
in case of generative model, how it is
generative
different?
model, we try to find out the joint density. That means what is the probability that this feature and this label will exist together. So okay, maybe we'll take the example. I'll
Okay, yeah,
yeah.
one example, sir. At least one example of both of the
Uh,
same type. Okay.
yes, so we can do that, and then we'll try to understand from there. Fine. So I'll take the same example which is there in the lectures, and we'll try to discuss on that. Right. So as we have already seen that what are the labels, right, and what is the data in general, right? So the example given in the lecture is about the spam and non-spam classification. So what is spam and non or spam, or generally it is called spam ham, but it's okay. So it is spam classification. What does that mean? So all of you have the email, right? And in that email you have a spam box, right? So whatever the spam emails are there, what does it? Spam emails means fraud, let's say fraud emails. So those fraud emails will go to the spam folder,
Spam.
right?
Yeah.
But how this Gmail or whatever the Google is working on over this, right? How they will know that this specific email which is sent to you uh, is the fraud email or the correct email? How it will categorize? So basically, it is categorizing, right? It is saying that given that whatever the email is coming to you, before coming that to you, so it will decide whether it will go to the inbox, your inbox, or it will go to your spam folder. So how does that engine will work, right? So or how does that model will work over there? So what does that mean? It is not like the sender will send you the email to your spam box, right? Right? They will send to you only your email
Yes,
ID.
ma'am.
It will be
Yes, ma'am.
decided in between. So from the sender, the mail will go, and then it will be decided based on that email whether it will go to your inbox or it will be go to your spam box, right? So sometimes, let's say IIT Madras is we are sending you an email, right? So sometimes it will come to your inbox. Some emails goes to your uh,
Spam, spam.
spam, right? Why it is that happening? So it will
Because
see
email,
some
email.
words,
Yeah.
yeah, and let's say if it is coming from do not reply, for example, right? And it will the engine which is work engine, whenever I'm saying, let's say machine, okay? So let's say one machine is there. So there is one sender, right? I'm sending an email, let's say, and there is one let's say there is a machine. What it does, it will check whether that will go to inbox or it will go to spam box, right? So let's say spam is equal to, let's say, negative class, and inbox is the positive class, fine, right? So whatever the email is there, it will check whether should I should so how many categories it will have to go for. That email goes for two categories:
Two category only.
inbox or spam, or I can say the positive class and the negative class. Is that okay? This fine?
Yeah. Yeah.
Okay. Now, what on what basis it is deciding is actually is based on the text, right? So email is full of text, right? So let us say if I give you an email, and now I'll ask you to categorize whether that will go to the spam or non-spam email. How will you decide? Let's say I have given you an email content, and now what you'll do is you'll read that email, right? You'll read each word, and now you'll feel that whether uh, that will go to the correct. So for example, I'll tell you one example about it. Let us say uh, I'm sending an email, right? Okay, let's say this is one lottery,
Lot.
right? So let's say congratulations, uh, congratulations, you have won the, let's say, like this. Okay, congratulations, you have won the lottery. Fine. Okay, this is
Yeah.
the content, and
Yeah.
there is another content that uh, or okay, it, let's say, looks like you have won a lottery by let's say competing uh, into that contest, right? Something like that. Like,
Yeah.
so what do you think? This looks like some fishy email, and this looks like an email sent by a friend, right? Let's say or not email. Let's say it is a text content, right? So do this looks like it's some of my friend has like if I oh, sorry, context, not contest, it should be context, right? So suppose you have won some contest, fine, some hackathon or something, and you have won some reward, right? And you thought like you should get like 100 rupees or something, and now you have earned more than that because you have you won the first prize or something, let's say. So this mail should go into what? Spam category, and this email should go to the inbox, right? Assuming that this is a or I know that, let's say, I know that this is from my friend and it should go to the inbox, and this is like, this looks like a fraud, right? So there are fraudster emails. I think you might, all of you might have seen those kind of emails previously. uh, so let's say this is a spam email and this is a non-spam email. Both of these email, what is common in that? Let's say Okay, and I'll say that, okay, congratulations on that, something like that is there. Huh? Okay, so this word and this word and this word, or this word, so these words are common in both the uh, emails, right? This one, this one, this one, this one, right? So if you are deciding based on the context only, how will you say that uh, whether this is a spam email or not spam email? So there is, you, because you have a human can understand this, right, by reading those emails.
Yeah.
But how does the machine will understand this, right? How does, because for machine, lottery one, congratulations is the same words which are appearing in here, also it is appearing in here. And in case of our let us say, in case of our classification technique, the data give, so we'll have to train that model, right, over that. So how to train that? You should get a lot of sentences, right, with their corresponding labels. Like say here the label is spam, and the, let's say the label is box, or I can say that it is -1 label and is, let's say, +1 label, whatever. But now we'll have to come up with some strategy so that we can be able to define a model for this part, and then uh, we can be able to classify properly. So now let us try to understand through the numbers here. Fine. Okay. So, and one more thing, can I say that uh, if I built a dictionary, right? So you have a dictionary of words, and in that dictionary, can I say that one of that word will appear in the text or it will not appear, right? So in the mail you can be appeared, or in another email it cannot be appeared, right? So is it, it's not necessary that the word is there in a dictionary, but that word will come to your email. uh, so either it will come or it will not come, right? Only two possibilities are there. Is that fine? That is understandable. If you are confused with this, let me try to showcase. Let me try to say that, let's say you have a short dictionary. Let's say I, U, M, R, of, fine. uh, right, so let's say this is a dictionary. Okay, so this dictionary contains how many words? 6 words, right? And if I wanted to create a sentence, how many sentences I can create? I can create like I think the combinations of all of this. But let's say I'll write down some sentences for you. Let's say I am fine, right? Then how are you? Or you are fine, like that, right? So you can see that here, let's say I, right, I will have how many choices here to appear in the sentence? Two, right? Is that fine or no?
Only one, na? I.
No, no. So let us say I wanted to create a sentence, a new sentence, right?
Yeah,
So
yeah.
let's say the sentence will contain only uh, let's say 3 spaces. So I need to
Three,
find out three
three
spaces.
words. Three
How
words.
3 words? Okay. In a sentence, you have 3 words, and the sentence can be formed only by using the 3 words, and
Hmm.
out of which, let us say, this dictionary. Is that okay?
Yeah.
So now I will appear here, or it will not appear, right? And the first
Hmm.
place,
Yeah.
right?
Hmm.
Here also same, and here also same, right?
Yeah,
So
yeah.
in each of the sentence, let's say this was the first sentence, right? In the first sentence, I appeared, right? But in the second sentence, does it appear? In
No,
the third sentence, does it appear?
no.
No, right? So either I will appear or it will not appear, right? It's kind of
Okay.
a coin, right? Either it will be a head or it will be a tail,
Mm-hmm.
right? Similarly for you, whether that you will appear into your sentence or it will not appear. Similarly for am, similarly for are, similarly for how, and similarly for find. Are you okay with that? So can I say that each of this word can be acted as a coin with head and tails, right?
Hmm.
Right. So any doubts? So what I'm saying that I will have its own coin, and it will either appear or it will not appear. And if it is appeared in the sentence, then I will say that one. Okay, one when it will appear in the sentence. Okay, that word will appear in the sentences. Then I'll say that it is one, and if it does not, then it is called does not appear. Then we'll say that zero. Is that fine? Is that okay?
Yes, sir.
So if I wanted this first sentence, if I wanted to uh, create from this dictionary, let's say this is a dictionary of 6 words. So what I should say now, I will appear, or I has appeared, right? So can I say it is one? Then does you appeared? No, right? Does M appeared?
Yes.
Yes.
M appeared. So can I say it is one? Does R
Yes.
appear? No.
No.
How appeared?
No.
No. Fine
No.
appeared. Fine appeared.
Yes.
So so this is my first sentence coded into some numerical values, right? Okay. So this is my first sentence. And so see, the machine will not understand like how we understand letters, right? Or words, right? We'll have to somehow say to like tell the machine, machine will only understand the language of numbers, right? For example, so it is like we'll have to somehow give the numbers to the machine so that it can work over that, because we have techniques to uh, uh, work with the numbers. Okay, what about the second sentence? So how this the second sentence will be coded? So it is zero, right?
One. Mm.
One, M
Zero.
zero, R
One.
one,
One.
how one,
Zero.
fine
Mm.
zero, right? Understand? All of you understood this? This is I, U, M, R, how, and fine. Okay, and by looking at these numbers, you will be able to understand. Okay, we are not able to understand here the, let's say, order, but at least we are able to understand that whether this word is present into that sentence or not. Is that correct? Order is
Hmm.
not, we are not able to understand. Let's say here, what is the, how does it look like? You, are, and how, right? But our exact sentence is how are you? Is that fine?
Yeah, yeah, yeah.
But order is not we are able to understand here, but at least we are able to understand that whether the word from this dictionary is present into that text, right, or in that email. Is that fine? Okay.
Yes, yes.
And now we will decide whether, let's say, I am fine is a spam email, for example. Okay. How are you is sorry, I'll say that it's non-spam email. So for non-spam email, I'll write ham. Is that okay? So non-spam is ham, and spam is spam. Okay, so let's say this is spam, and your fine is ham, let's say. Okay, so these are the labels, right? This is what, this is your data point,
Data points.
and this is your label. So uh, what is the corresponding data point for this sentence?
It
Ham
is a
is
first data point is the
plus.
having the three feature, right?
Features, you don't worry about the features right now.
Okay, okay. Three
uh,
words. Three
yeah,
words.
3 words, like let's say for simple understanding, and then we'll
Mhm.
convert that into the features later
Okay,
on.
okay, 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 fine.
What about second? So the corresponding label will be -1, right?
Minus one
And
plus one.
similarly, I can write for so your fine is 0, 1, 0, 1, 0, 1, and that is +1. Is that okay? Correct. So what we have,
Sir,
yeah, yes, yes.
so sir, how this number two got -1?
Because see, we just supervised learning setup. In supervised learning setup, what do we say? In supervised learning, we have the information about the labels also, right? Along with the data, correct? Okay. During
Yes, sir.
during our training, I am telling you already that this I am fine is a ham and how are you is a spam. You are fine is a ham, okay, or non-spam. Is that okay? Because it is there. So when you collect the sentences, see if I let's say if I given you the task to check whether these emails are spam or non-spam, and how will you learn about that? Let's say you don't have any understanding of it, but how will you learn as a human? What you do is you read like thousands of email, right? And based on that, by reading all that emails, what you do is you label those emails as spam and non-spam, and that is what the machine will have already. So the data which is there during our training, right, that is already given me with the labels. Is that okay?
Uh, sir, so that this -1 and +1. So
uh,
this you are from your side yourself giving this. This will be +1. This is a spam and this is not a spam, isn't
yes,
it, sir?
yes.
Okay, sir.
So your machine will learn over this data, and what it will do, let's say there is a text data point. Text data is like this. It says how I am. Okay, okay, and now predict what is the, or let's say why predict. Let's say predict what is the label for this. Now you don't have this, right? So you are learning from here, and now you're going
What,
to find out its prediction. So
what
what
is
will
test data? Test data?
test data point is the data point for which you need to find out the
No,
prediction,
no,
right?
no, no. What we have written is
How I am. It's some other
how how I am. Okay,
uh,
okay, okay.
some sentence. So
Hmm.
it is some sentence is given to me, and now what is your task? Task is to say that whether it is spam or non-spam email, right?
Hmm.
Okay, and how will you do that? You learn it, learn something from the data which was there with you, and from there you will try to find out whether what is the label for this email or not. Is that okay?
Yeah, yeah.
Okay. Now what we have, let me try to all like establish all of these things into mathematical form now. Fine. So what I said is there is a dictionary of word, right? And now from the dictionary you are trying to what, uh, uh, trying to check whether that word is present into that spam email or not spam email, right? So let's say lottery is the word given to you in the dictionary, right? So what do you think, it will have either it will appear or it will not appear, right? Is it correct?
Yeah.
So can I say that it is a feature? Okay, one of the features, and it will take two values only, right? Is it a Bernoulli random variable?
Hmm.
Correct. Suppose lottery is there, and that lottery will appear into your text or it will not appear. Only two choices it will have. That word. Each of the word in the dictionary will have how many choices?
Two.
Two choices, either 0 or 1. 0 means it will not appear, 1 means it will appear. So suppose this lottery, I will say that it is one of the random variables, fine, or
Hmm.
feature. We treat it as a feature. So whatever the words are there in the dictionary, each of the word we treat it as a feature, right? Is that okay?
Feature or random variable?
Feature is a random variable, right? Each
Ah,
feature is
yeah,
a
yeah, yeah.
random variable, right?
Yeah, each feature. Correct, correct. X. Yeah.
Right now, because
Yeah.
that's how it is working, right? So and now it will have how many choices? Only two choices, right?
Only two choices.
And if it is a random variable, that means what is associated with that? Probability, right? So
Hmm.
there will be a probability associated with that word. So let's say lottery is a word, and now one of the words is, let's say, uh,
One.
huh? One, no, not one. Let's say any positive word you think, whether officially positive, let's say any good word, let's say. or doesn't matter, but let's say, okay, I'll take one word. Okay, let us say this is xi, and this is also another feature. It will also have two values, right? It will take only two values, right? And it will have some probability associated with. So do you think that each of this word will have 0.5 as a probability, or it will differ? So does lottery, if it appears into your uh, uh, okay, again, the thing is that this lottery word can be appeared into spam email as well as non-spam email. Is that fine? Is that correct?
Yeah.
Yes, sir.
No issues with that part, right? So if lottery comes into the spam email, uh, and also non-spam email, so what is the probability, will the probability of appearing that word lottery into spam email will be higher, or the probability of that word lottery appearing into non-spam email will be higher?
Spam will be higher.
Spam will be higher, right? Correct. So
I don't know. I don't know. Once again, what are you
So,
telling?
okay, what I'm saying is this lottery, this word, right? It can
Yeah.
occur into your spam email as well as it will occur into non-spam email. For example, we'll see this part. So you can see that this fine word, right? Uh, okay, not fine word. Which one is okay? Let's say R, right? This word,
R. Yeah.
right? Uh,
Hmm.
this word R, it appeared here also and here also, right?
Yeah.
Correct. And
Hmm.
it appears into the spam as well as non-spam, right? Correct. Similarly, that lottery also can occur in spam or non-spam, but the probability associated with it occurring into spam email will be higher than that of non-spam, or not? Or does it will have the same probability in occurring spam email as well as in non-spam email?
How will decide it whether it is
No, in general, deciding, I'll tell you how will you decide.
okay?
In
Okay.
general, what do you think that when the lottery comes into your mind, it is it's most likely that it will occur into your spam email,
Spam. Spam.
right? Most of the times, it might occur into your spam email, and
Yeah.
it is very unlikely to occur into non-spam email, right? Is that correct? Right?
Less likely.
Right.
May
So
occur. May occur.
correct, right? So spam. Let's say, so that means for the spam email, the probability of it this will occur, let's say it is 0.7 here and it is not occurring is 0.3. It
Yeah.
is not like every spam email it will occur, that also is not possible, right?
Yes.
But let's say it's higher probability, and for non-spam email,
घर में कोई नहीं है खोल दो इसी चल रहा है इसको खोल दो
so for non-spam email, this word lottery occurring, it will also have some probability, right? But will that be same as that of occurring in the non spam email? No, right? So it is possible that it is like this. Let's say this the distribution is like this. Now you understand this part. At least this part is fine.
Yeah.
Okay, is that
Yes.
it's
Yes.
clear, right? So each of the word will have the probability distribution in the spam, which is a different distribution in the spam, and it is different distribution in non-spam, right? Correct.
Yes. The same word you have the different distribution.
Correct, right? Yeah.
Yeah.
The probabilities are not similar. Now,
Mhm.
now can I say that, let's say if I have a data, and data will contain what? Let's say uh, features, right? So let's say x1, y1, and suppose these features are text features, right? And what are their corresponding labels?
Y1, Y2.
Uh, yeah, but what are they? Why each of y will take what values?
10.
1
1 0.
0,
1
right?
0 only.
Or I can say the spam or non-spam, and each
Hmm.
of
Yeah.
xi will take what values? Okay, each of xi is what? It's a
Text. Word.
sentence,
Word.
right?
Word. One word. One word.
Correct, right? But how we are representing that word now?
Hmm.
Like this, right?
In one
Or
zero, yes.
not
5
word,
to 0,
sentence,
5 to 0, 1, 1, 0.
sentence, right? Correct. Correct.
Yeah.
And it depends
We,
on
we,
what?
are, we are representing a sentence like this, not word.
Correct. But each of this xi, this is x1, right? This
Yeah,
is x2, this is x3, right?
yeah, correct.
Right. Entire email.
Three sentences we are representing like this, right?
Yeah. But that x1 is what? The data point is actually a combination of words, right?
Yeah,
And how I am
um,
representing that? By using
by
a dictionary.
0.
Yeah, 0 1 it is okay. And okay, let's say 0 1 is there, and uh, how many words are there in this dictionary? Let's say this was a dictionary.
Yeah, this is about 1, 2, 3,
6, right?
4, 5, 6. 6 words. Yeah.
6, right? So, and
Mhm.
each of it will have 0 1, right? So each of this word will have 0 1 associated with it. So can we say that
Correct. Correct.
each of xi belongs to what here in this case?
0,
Is
1.
0 1 in 6 dimensions, right?
6 times. Yeah, 6
Correct.
dimensions.
See, x1 is equal to this.
Yeah. X1 is 6 dimensions. Correct.
So if I think this as a vector, it's a vector in what? How many dimensions? 6
6
dimensions.
dimensions. 6 dimensions. Correct.
And each of this one is actually taking two values, right? Either 0 or 1. 0 or 1 or 0.
Yeah.
Now understood. So let us say in general, how should I write this? So each of this xi will be in, this is either 0 or 1, it will take 0 or 1 and in d dimensions, right?
D dimension.
And what is d here? It's a number of
D is
words,
the number of features.
words
Number of words here.
in the
In
dictionary, right?
the dictionary. In the dictionary.
Okay, I hope all of you understood this part. And each of yi is what?
0 and 1.
Okay,
Yeah.
correct. I think I am assuming that you guys are understanding this part, right? Okay.
Yes, sir.
So now let us say there is this sentence, hello, and what I said initially is that the same word will have different distribution in spam and non-spam thing, right? This is okay. This part is also fine.
Yes.
Okay.
Mhm.
So let's say hello, how are you? If this is a sentence given to me, can I find out its probability of occurring? Let us say only, let's say this is x, right? This is your x, right?
But hello is not in our dictionary.
No. Now, don't only consider this one. Now, this was for like understanding purpose. Let's say your dictionary.
Okay, got it. Okay. Every time it is created dictionary, right.
Yeah. So now you consider a entire dictionary, whatever is there. Okay, is
Hmm.
that fine? And now, what I'm saying is, each of this word will have uh, each of this will have what its own distribution in for spam and non-spam, right?
Hmm.
So x, if it is x given like this, corresponding y spam, I need to find out its probability. And again, that x, hello, how are you, non-spam, right? Is that fine? So if I
Okay.
want to find probability that,
Probability of X, whether it is a spam or non-spam.
yeah, so x given spam. So let's say x is the sentence,
Hmm.
and x, and it is spam, right? This some probability will be there, and let's say x, y given non-spam. Will these two probabilities be similar or different?
Different.
It will be different, right? Because
Different.
yeah, for because it is a joint density of what, this sentence appearing in the spam email, right?
Hmm.
And how generally, how will you, let's say if you are a human being, how will you calculate this probability? You have, let's say, 10,000 emails, right?
Hmm.
Okay, what you do
Hmm.
is, and you have the 10,000 emails and its corresponding labels, right? Whether that email is spam or not spam. What you do is, how many times uh, this sentence is occurring into that email, And this what you do is, let's say in that you have, let's say 10,000 emails. Okay, number of emails are 10,000, and its corresponding labels are there as spam and non-spam. Okay, let us say in 300 emails this sentence appeared and it was marked as spam, and in, let's say 500 emails this sentence occurred and it was uh, it was labeled as non-spam. So what is the probability that this sentence occurred in the spam email? It is 300 divided by
By
1000,
the 1,000.
right? And what is the probability that this sentence occurred in the non-spam email?
10,000, no? Is
Yeah,
it 10,000? No?
it's okay. Okay,
Yeah.
it's a number.
Mm.
Anyway, so I
Mm.
would say that 500 divided by 10,000. So that is equal to 0.05. That's how we will calculate, right?
Yeah,
But
yeah.
but what you have done here is you have seen the sentence, and at the same time you have seen that label, right? So this is the joint density, correct? So whatever you have calculated here, it is joint density, and this joint density here it is, let's say 0.03, and it is here 0.05. Okay, is that fine?
Yeah, yes, sir.
Right. So just remember this part, because whenever later on when we try to predict, right, we'll use this understanding. But I hope till this part is fine, no issues till now, correct? Okay.
Yeah, yeah, ma'am. Yeah, yeah.
So one more thing, we know from statistics that this joint density can be written as what? In
PXY.
case of a conditional density distribution, how should I write it?
P given X.
P of y given x into P of x,
PY. Yeah, P of X
or
divided by.
or P of x given y into P of y. Both will be same, right?
Mm. Mm-hmm. Both will be same. Both will be same.
So here
But
what is,
divided.
no divided, no, it's not there, right? It's a joint density. So what is the conditional density? The probability of x given y,
Okay.
it
Oh,
is
okay.
probability of x y divided by probability of y, right? And probability
Y.
of x given y, oh, sorry, not, it's the same thing. Writing y given x, y
Y
given
given X.
is probability of
Probability of
x
XY.
intersection y, or
Probability X.
given
Probability X.
probability
X.
of x. So if I multiply
Mm-hmm.
with this, right, I'll get this.
Mm-hmm.
If I multiply this with this, I'll get this. So if I equate it, so it is like probability of x given y is here, from this equation it is probability of y into probability of x given y, and here probability of xy is equal
Probability
to
of X.
probability of x into probability of y given
Of
x.
Y given X.
So this is equation 1 and this is equation 2. So from equation 1 and 2, what we can conclude is probability of y into probability of x y is equal to probability of x into probability of y given x, right? And that should be equal to the joint probability, right?
Mm-hmm.
Hmm? Okay. Uh, till now it is fine, I guess. Now, what we are saying is, now this is called as a generative modeling, right? And how will you generate a model is,
Just go back. Probability of X given Y, no, in the second. Probability of Y into probability of X given Y, no?
is given, yeah.
Right. Okay.
Now, from this, we can actually find out the generative story. What is the generative story or generative modeling? What do you basically do in generative modeling? You try to find out the joint probability. Given the email, like what is the probability that the given email uh, and its spam corresponding spam email is there or not, right? Okay, and how will you find out whether that okay, what is the probability? So why I said, right, it will take what, two values, right? Either 0 or 1, or -1 or +1, right? Positive class, negative class, or 0 or 1. But what is the probability of y equal to 1, and what is the probability of y equal to 0 in this case? How will you find it out? In this, let's say 10,000 emails are there, and if I say that in 10,000 emails, total spam emails are 400 and non-spam emails are 600. Okay, so what is the probability that y equal to 1? Y equal to 1 means, let us say it is non-spam.
It is non-spam.
Okay, so what is the probability that the given email is non-spam? How will you find it out from the given data? In general, like
600 by 10,000.
600 by 10,000.
10,000, right? Okay, so then it was 10,000, huh? Then I should have
10,000.
this. Sorry, then it should be like this, right? So
4,000.
because all the emails will either be spam emails or non-spam emails, right? So the probability of y equal to 0 plus the probability of y equal to 1 should be equal to how much? 1, right?
Pardon. Once again, what you told?
So the number of spam emails and so what is the probability of y equal to 1, which is probability of y equal to spam email or non-spam email, plus the probability of y equal to spam email should be
The
equal
one.
to 1, right?
One.
So,
Yes.
so that means it's like it should be 4,000 and 6,000. Let's say 400, 600 will be wrong.
4 by 10 plus 6 by 10.
So the probability of y equal to 1, which is what non-spam, will be 0.6 and it will be 0.4. Is that okay?
Yeah.
So, so each of these labels, right? This we have 2 labels only, so they will have some probability. And can I consider this y as a what is it?
Non-spam.
No, as a coin. Can I say it is a coin? Again, this label is a coin, right? It will have only 2 outcomes. Which are these 2
Yes.
outcomes? Spam. Either it is a
0.
spam or it is a non-spam, or 0 or 1, right? And then we have to find out whether that is a okay. I need to find out anyway this, right? I need to find out this. What is probability of y, or what is probability of x? Is probability of email, right? That email. And probability of y is what? Probability of
Spam, non-spam.
y, yes, either it is spam or non-spam given the email.
Given
Right?
the email.
And here is probability of spam
Spam
and
or
probability
non-spam.
of email
Email given.
y, let's say, right?
Exactly. Yeah.
So either I can, if I wanted to find this joint probability in generative models, what we should do, we have to find out the joint density, right?
Joint density of x and y.
Correct. But I can find out this joint density
Joint density of the
email and
sentence. Email and
corresponding label,
corresponding level.
right? So it can be like you need to find out probability of this sentence given the spam plus not plus, and probability of, let's say, given email and non-spam.
No,
Now it will have, let's say, 0.05 probability, and this will have, let's say, 0.03 probability. So whatever the feature is there, no,
both should be one, na?
no. This cannot be 1, right? Why it should be 1?
It
Okay,
is a probability.
sentence. Okay.
They are separate, right?
Separately.
Correct. So I have given you that information, right, before, like that example I have given you.
Mhm.
So what do you think about this email? Or what will be the label for that email?
It
By
will be
looking at this
spam.
one? It will go to the spam because it will have the higher probability, right? That's how you actually decide. But to come to that decision, I need to find out what first, this thing, right? This thing and this thing, right?
Mhm.
And this thing I can find out by either calculating this part, or I can calculate this part, or whichever values I am having currently. So the generative models, right, or what they do is, first of all, because I said, right, it will be a coin again. This y can be considered as coin. So I'm using the same terminology, whatever is there in the lectures, so that we will not get confused much, right?
Why coin was introduced? Coin.
Coin, because see, because we known that everything in terms of coin, right? So Bernoulli distribution.
Bernoulli.
Yeah,
To introduce the Bernoulli type of distribution, we introduced coin to understand. Is it?
yeah, because then only it is understandable, right? Because every coin will have only 2 choices, either it will be head or tail. Similarly,
Got
here
it.
we have only two choices.
Okay,
It's a
sir.
Bernoulli distribution basically.
Only for that we
Yeah,
have to
it's
discuss.
analogical, right? The analogy is there
Okay, okay.
of a coin, so it is understandable easily. It's basically a Bernoulli distribution. So how to find out the probability of yi equal to 1? And let us say this is p. P is what? Probability of success, right?
Probability of success.
And success can be, it can be, let's say if you define the success as getting a spam email, then it will be y equal to 1 will be spam. If you define it as getting a non-spam email, then y equals to 1 will be non-spam, so that the probability will be associated with that. Is that okay?
Mm-hmm.
So if I know this, will I know the probability of yi equal to 0?
1 minus p.
1 minus p, right? So
Hmm.
here I don't need both the value. If one is there, I'll be able to find out other,
Yeah.
right? Because
Second
it's a
complementary.
so what you think is, what you do in this generative modeling is decide the label, right? And how will you decide? You will calculate its probability. And in general scenario, what I said to you, how can we do that? If you have 10,000 emails, and if I know that 4,000 emails are uh, marked as spam, and 6,000 are marked as non-spam, and let's say y equal to 1 is a what is it, non-spam email, then what will be the p here, the probability of success? It will be 6,000 divided by 10,000, right? 0.6,
Mm-hmm.
right?
Pardon, once again.
Yes, sir.
If I said you have 10,000 emails in real life, let's say, how will you
Yeah.
do that? You have 10,000 emails in
Yeah,
the
yeah.
training. In the training, I have labeled like 6,000 emails as non-spam and 4,000 emails as
Yes, the span.
spam. Let us say y equal to 1 is what? Non-spam email.
Non-spam.
So what is the
6
probability that y equals to 1?
0.6.
0.6, and that's it. So that's how you calculate in real life.
Hmm.
That will be the value of the small p, right?
Hmm.
Small p here. So that's how you'll find out small p. So you will find out probability of y equals to 1. And what is the next step you'll have to find out? Because you need this, right? You need this. So you have found out this part. I need to find
Hmm.
out this part, right?
Hmm.
Hmm? Okay. And how will you do
Yeah.
that? Once you
Probability
find
x
out this,
given y.
you will find out probability of xi
X given y.
by I, right?
Probability of y into probability of xy.
Right?
Hmm.
Okay. So now we have seen one example previously. It was this example, right? Correct.
Mm-hmm. Mm-hmm.
So how many features we had at that time?
6.
6 features, right? And
Hmm.
each will have that 0 1 0 1 thing, and can uh, and we'll have to see that it will have like different probabilities for what, different
Different words.
words, right? So that is correct.
Hmm.
Okay, so now we don't take that examples. Whatever, like we'll take the simplest example here, only of 3 words. Okay, you have 3 words, W1, W2, 3, right? Correct.
Hmm.
And
Mm-hmm.
this each of W1 will belong to what, or Wi will belong to what? 0 and 1.
0, 0, and 1.
It will take value 0 and 1, right? Okay. For the spam case, will this each of this word will have different probabilities associated with it, right?
Hmm.
Is that okay?
Hmm. Yes.
So what are those? So okay, how many combinations can be possible with this? So can I say that it is x? Each of xi is now 0 1 in how many dimensions? 3.
3 dimensions.
So how many possible combinations are there?
8.
8.
8.
I wanted to create
2, 2
sentence,
to the 2 to the power 3.
right? And so what are these 8 combinations? The sentence
8
can
is 0, 0, 0, 0, 0, 1,
be 0 0 1
0, 1, 0,
1 0
100.
100, 100, then
101,
101,
110, 1111.
11, right? Right? And this is
Yeah.
and it will have a different probability for spams, right? And it will again the same combinations will be there, but it will be
Not non-spam.
right, and it will be like all these 8 possibilities will be there here as well, right? And its associated probability we can find it out. And will these probabilities be same or different? Different, right?
Different.
Any doubts till now? Are
The
you guys?
same thing will come. No, same thing will come. No, 000, 001.
Yeah, so I'm not writing it down, but yeah, all this same
Yes,
sentences will
the
be
same
there.
will be there. No, the probability will be same. No,
No, probability will not be same, na? Okay.
probability over 1 minus that. Yeah.
Not 1 minus that. It's not here. So I showed you one example of this word, lottery. The probability distribution is different, right? Let's say I'll take this example there. Can you tell me? Okay,
0.3 and
I'll tell you,
0.7.
and assume that all of these words are occurring independently, so that I can be able to find out its probabilities very easily. Let's say, uh, so let's say W1, right? W1 is word, and the probability distribution for it is like this. So for W1, it will take 0, 1, right? The
Yeah.
probability, let's say 0.1 and 0.9 for spam. Okay, and for non-spam it is W1. The same word 0, 1 will have a probability as
0.9 and 1.
no. Why?
Okay, different.
It can
Okay,
be
it will be different. Yeah, it can be different.
right. And for W2, again it will take two values. Let's say for spam case, this is one, here, let's just for spam case it is point. Okay, spam, right?
0.3, 0.7.
Yeah, let's say 0.6 and zero point 0.4. And for W2 here, in non-spam case, probability is like, let's say, uh,
For a spam case,
hmm,
it should be one should be more probability, no? Then it will be a spam, no? 0.4 and 0.6.
no. Occurring, that word occurring into that sentence, spam sentence.
Okay.
See, this
Okay.
okay, I'll tell you again.
Mm-hmm.
See, this lottery, right? Lottery comes into the spam email, right? Uh, its probability is not like okay, maybe basically I'll write down some uh, examples, right? Suppose I say I lottery, okay, I lottery, uh, lottery one, uh, and
Okay, got it. In the each sentence, it will be different, right?
lottery I won. Okay, whatever. I don't know.
Mm-hmm.
Something I'm writing like this.
Mm-hmm.
And
These sentences are there.
say lottery I, okay, one I lottery, and uh, I,
One lottery.
let's say, okay. So you can see that the two words, right? Let's say, and this is spam email. This is spam email. This is spam email.
Mm-hmm.
I'm not. I'm just writing it down. Fine, absolutely. And this is non-spam email. This non-spam email, right? And
Mm-hmm.
similarly it's non-spam email, like that. So these are the examples where all of these words actually occurring simultaneously, but sometimes it will be said to as spam,
A
and some
spam, sometimes it
non-spam.
is not a spam.
Again, it depends on whatever the order we are actually doing it, and it depends on uh, by human understanding also, right? Like I know that okay, this is how it is, right? So this lottery will have different probability when it comes to the spam thing.
Yeah, yeah.
And how will you do that? Let's say you have such 5,000 sentences, total 5,000 sentences, let's say.
Mm-hmm.
In 5,000 sentences, in let's say, uh, 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 or okay, not 5,000, let's say 500 sentences. I'm saying that there are 200 sentences, okay,
With
where
a spam.
yeah, where I labeled as spam, and that lottery is present there. So what is the probability that lottery comes into the spam email?
2 by 5.
It will be, let's say, 2 by 5, right? And in the
Mm-hmm.
non-spam email, that lottery word occur only, let's say, 50 times. Okay. So
Mm-hmm.
what is the probability of lottery in case of non-spam emails?
50 by 500 means 1 by 100.
Or let's say 100 by 500. So it is 1 by 5. Okay.
1 by 5,
So,
yes.
so for spam thing, spam emails, the probability distribution for the same word lottery, it is 2 by 5 and 3 by 5, right? Let's say it is 1 0, correct? It will appear or it will not appear.
Mm-hmm.
For non-spam cases, the word occurs, right? Uh, let's say it will be, let's say, 1 0. It is 1 by 5 and 4 by 5. So the
4 by 5.
probability distribution for both this will be different. Do you get that?
Yes, yes, yes.
You can actually okay. I have
Yeah, yeah.
take
No,
some
no.
random example. It
Mm-hmm.
may be right or maybe not be right, but the thing I wanted to tell you is that the same this word, right, appearing
The
into
same word will have the different probability for
probability
different.
distributions for
Yeah, yeah.
spam and for non-spam. So it will have same different probability distribution for spam, and it will have
Mm-hmm.
the different probability distribution uh,
Mm-hmm. Correct, correct.
for
Okay.
non-spam, right? And
Mm-hmm.
accordingly, its probabilities will be there, and the probabilities, since they have different probability distributions, the probabilities will be different for them. And then, because let's say, then the probability given this sentence, right? Okay, probability given this sentence, and it will be equal to spam, will be different than the probability of y equal to non-spam given the same sentence.
It's different.
It will be different, right?
Correct, correct.
Right, and you can see that example into the lecture where sir has given some values to these probabilities, and
Mm-hmm.
it's decided based on that. So what is that? We have one coin, right? What was that coin? The label coin, right? Correct.
Mm-hmm. Yes.
Y coin. And and what is the distribution for what is the parameter there for that y label? P, right?
P, P.
This p is a parameter. If p is or if y is equal to 1, it will, the probability will be p, right? And if y equal to 0, the probability will be what? 1 minus p.
0.
1
Uh,
minus p,
yes, yes.
right? It will have
Correct.
only two. So what will be the distribution for y here? Labels will have the distribution like this. Y will take values 0 and 1. Y will take values 0 and 1, and the probability of y equal to this will be what? This 1 minus p, and this p. Is that fine?
This is P. Yes, it's fine.
Okay. Now that means whenever I toss a coin of y, I'll get either 1 or 0. And if I get 1, right? So let's say 1 is what? I said spam, right? Now
Yeah, one is a
I get a
spam.
spam. Then how many words I'm having in that?
3.
3 words. So can I say it is a dice of 3? Or because we are saying like it's a 3 features, right? Basically it is a d features, but let's say three faces are there for this dice, right? Hmm?
Mm.
And it will have some probabilities associated with that. So let's say these are 0.01. So this is corresponding to w1. Let's say this is w2 is 0.1, and this is w3, which is 0. Let's say 1. Okay.
Mm. Mm.
And in the non-spam case, again, do I have the 3 words or do I have more words? 3 words only, right?
3 words only
But
with
do they have
different probability.
yeah? So let us say this probability is how much? It's 0
One is
0.1.
0 to, yeah,
Say it is
different.
0.02 is W2. It may be different or it may be same.
Yeah, maybe semi different.
Yeah,
It
W3,
is independent of the
correct.
spam, right?
And it will, yes, and it will have some probability. Okay.
Hmm.
Okay. Again, so this dice has to be like not W1, W2. Basically, I'll have to find out the probabilities associated with entire sentence, right? Entire feature. This is my x1, this is x2, this is x3, x4, x5, x6, x7, and x8, right? So sorry, I just missed that part. That is okay. But so okay, the dice will be what then? How many faces it will have? 8 faces, right? Total 8 faces, and each will have different probabilities, right? Is that correct? Similarly, this non-spam dice will also have 8 faces with different probabilities. Is that fine?
Yes, sir.
I hope no issues are there.
No.
Okay. And each of these x1 will have how many choices?
Cool.
Can I consider this as what are those choices?
0 and 1.
0 and 1, right? That means uh, this will appear in the spam or it will appear in the non-spam.
No, spam.
Correct, right? So correct, and it will have its own different probabilities.
Yeah.
Or I can say that each will depends on like number of words which are there. Okay. I hope
Each will depend on number of words. Yeah.
or
Okay.
okay, no, not x1 will have two. Let us say x1 anyway will have, but x1 is consist of what, like here? How many words?
X1 is considered 3 words,
3
no?
words. X2 is consist of
3 words.
3 words, right? And similarly like that. And
Yeah.
each word will have
And each X1, X2 will have different probability.
or each. Okay, so now if you have xi belongs to, let's say, 0 and 1 in 3 dimensions,
Yeah.
correct? So what does that mean? X1 will have W1, W2, W3, and that will be 0, 0, 0, correct? So I need to find out its probability, right? And okay, that is one parameter, right? Here, find out. So W1 will be a coin, right?
Yeah.
W1 will be a coin. W2 will be a coin or Bernoulli distribution. Will it have Bernoulli distribution? Each of
Yeah.
each of the word will have a Bernoulli distribution. So
Mm.
can I consider all of them as a coin?
Yeah.
Hmm?
Yeah. Yeah. Yeah.
Or here in this case, what we are doing? In this case, actually, we are not considering them as coin. Okay, but yeah, later on anyway we are going to. But right now, how to decide all of that? Like, what is the probability of x1 in this case? If it is 8 faces, then what is the probability of x1? It will be some probability, right? Based on
Yeah.
the words we have chosen here and the mail which is given to me, the spam email. It will like let's say 0.1. So x1 will be a spam email. What is the probability of that?
Probability of being a spam.
So
Mhm. You are asking
Very
probability of
low. Very
probability of X1 or probability of W1?
no, x1.
X1.
Yeah. So we wanted to find out. Okay, in generative models, what you need to find out is
3 by 8, no?
yeah. Okay. Correct. So that is there anyway, but proud of y into what you need to find out is probability of y, not y. It's given now.
Probability of X given Y.
X given.
Yeah, Y.
So
And
in that case, what you do, you decide a label first, right? You get you get its probability, and then based on that label, whether it is spam or non-spam, what is the probability that this X will appear? Is that correct?
yeah. Yeah, yeah. In that spam or non.
Correct, right?
Mhm.
Hmm? So for that three letter thing, right? We said that you have three words, W1, W2, W3. X1 will be 000. Suppose X2 is what is it? 001.
Yeah.
X3 is 010,
One.
like that. And we have eight things. And what is the probability of X given Y equal to spam? This is this probability, right? Say it is 0.1, 0.01, 0.02, and like that. Fine. You're understanding this point? And uh, x4, x5, how many words how many sentences it can form here? Total 8 sentences.
Eight sentences.
If I calculate the sum of all of them, what that will be?
1.
It should be equal to 1,
One. Total one. Yeah.
right? And similarly, probability of X given Y equal to non-spam, right? The same kind of combinations will be there, and their probabilities also will be equal to how much?
One.
1, right? Now, when I say that probability of Y, uh, what and why I consider as either it is a spam or non-spam, and we have decided that it will have one parameter. What is that parameter? P, right? Bernoulli
P.
distribution, that probability of success. So if I wanted to estimate the parameters, how many parameters I need to estimate? In this case, total number of parameters. So one parameter is for the label, right?
Yeah.
Whether it's spam or non-spam. How many parameters do I need to do for this case?
Eight.
8 or 7?
Mm. Seven.
Because I know the probability of all of them will be equal to how much?
Yeah. So 7 will be there, and eighth one will be 1 minus that, right?
Correct, right? Is that correct?
Mm.
And how that 8 combinations are coming actually? 2 to the power 3.
2 to the, yes.
So the 2 to the power 3 is like 8, and minus 1. That many parameters I need to find out,
So
right?
why are you considering 7?
Okay, so because this total probability is like, how much is the probability?
1.
1, right? So if I know, let us say this is uh, can I say that this, let's say it is P1, is one parameter P1, this P2 is P3, right? And like that, how many parameters do I need to define here?
P8.
Right? But I know that P1 plus P2 plus P3 up to P8 is equal to how much? 1. So if I
1.
estimate these parameters up to P7, can I get the estimator for P8?
Yes.
And how will I get it? Because I know that this relation is
Equate.
there, this,
Yeah.
right? And I can just like find out P8 equal to 1 minus. So, and each of this P1, P2, P3 is what, like we are considering them as anyway Bernoulli, right?
Right, sir.
Mm.
So anyway, that is okay. That is another part. But okay, so how many parameters here I need to find out? 8 means 2 to the power
B
D.
minus
D, right? Number of features. And in this case, the features were 3. And in general, how many? If the dictionary is of D words, it should be
D.
2 to the power D.
The,
That many parameters minus the 1. Is that okay?
yeah.
So
And
why minus 1 again? Like,
yeah, that is what I said. No, here how many you
eh,
need? 7,
so
right?
why we are taking only 7 to just estimate the one probability of that like P8?
Mm-hmm. No. I see. I need the estimator for all of them, right? Anyway,
Yes.
right? For P1 to P8, how many parameter estimators I need here? In this case, 8,
8.
right?
Right, sir.
But uh, so okay, in Y case, how many parameter estimates I need to look at?
2,
2,
0
right?
and 1. Uh,
P and 1 minus P actually, right?
yeah.
But if I know P, do I need to find out the estimator for 1 minus P?
No.
No, because if I know for estimator for P, I will just subtract that, right?
Okay.
So
Okay.
only
Got
one
it.
I need there.
Got it, sir.
And similarly here, you don't need all 8. Once you find out 7, definitely you'll be able to find out the 8th one. Like that means you don't explicitly need to find out that parameter 8th one. Correct, right?
Got it, sir.
So if you have deep features, then how many parameters estimators you need? 2 to the
2
power,
to the power d minus 1.
and that is for spam case.
A span case.
And for non-spam also,
Same. 2 to the power d minus 1.
right? So the total number of parameters will be what? So this is like 2 times, right?
2 times.
1 plus 2 times 2 to the power d minus 1. That is
Yeah,
1
yeah,
plus
correct.
2 to the power
D plus 1
minus
minus 1.
2 multiplied, right?
After
Multiplied.
ultimately 2 to the d plus 1 minus 1.
Yeah, so it is 2 to the power d plus 1 minus 1. So that many parameters you need to do. Is that okay?
Yes, sir.
Yeah, but if
Okay.
your dictionary size is too large, let's say it is like 1 million words are there, 1 million, 10 lakh words are there. So how many parameters do you need to estimate? 2 to the power?
NP hard. NP
Yeah,
hard
2
problem.
to the power 10 like
yeah,
something.
right? Almost like that many. So it is like very huge number of parameters
Difficult.
you need to do. And why we needed to do that? Because we were actually we are treating this as the probabilities instead of we are finding of these probabilities, right? We are actually understanding that, or we are trying to find out the probabilities for what? Sentences,
Spam.
even the spam
Sentence.
sentences,
Yeah, yeah.
spam, but we are not actually looking into the words. So let us say if I look into the words instead of sentences, what will happen now? So if you have 3 words, w1, w2 and w3, so instead of finding out this, or making this x1 as the coin, right, I will make this w1, w2 and w3 as a coin. I hope you understand the coin concept, right?
Yes, sir.
So if I, for spam classes, how many coins I need? 3.
3.
3.
And for non-spam, how many?
3.
Same.
Again 3, right? And so it will have, let's say, p1 and 1 minus p1. This is p2 1 minus
P2
p
1 minus P2 and P3 1 minus P3.
1 minus p3, and here uh, again p1
Again,
1 minus.
P1 1.
What is the difference here? Let us say spam is considered as 1 and non-spam is 0. Okay, how do you want to do that? Like I will make it consistent. Spam as 1 or non-spam as 1?
Better, sir. Spam is 1 and non-spam is 0.
That's fine.
Yeah.
So let's say I'm writing this as, what does that mean?
So it belongs to
The spam,
spam.
right?
Hmm.
And when I say 0, 0, let's say, then this is p2 0, 1 minus p2 0, right? And it will be p3 0, 1 minus p3 0. Is that okay?
Yes, sir.
All of you understood these notations? What p1 of 1, what is this notation?
P1 minus P11.
So no, what does that mean by, what do you understand by that p11?
The
Belongs
probability
to
Our first data point belongs to
Not data point.
data word.
Yeah.
word.
So let's say that for first that word, right? The probability of success belongs to that. Okay, let's say if that word belongs to the spam, the probability of success for that word 1 is this p11, right? Correct.
Pardon, once again.
So let us say it contains spam, right? So
Yeah.
so this word will appear into spam email, right?
Hmm.
And since it is a word 1, let's say p1 is the probability of success associated with it.
Hmm.
Okay. And p01, what does that mean? The same word is appeared into
Non-spam.
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 This is for non-spam, right? This is for spam. And now, will this p10 and p11 same or different? Like in general, the probability of success for that word one appearing into the spam, and the probability of success for that word one appearing into non-spam will be same or different?
Different.
It will be different, right?
It will be different.
Correct, right? Because let's say this was W1 was the lottery, right?
Mhm. Correct.
Lottery appearing into non-spam will have different probability, but that word is same, and that is why it is denoted by. So this one at the or the subscript, right? This is actually belongs to that word, right, in that sentence, and this belongs to the class label. Is that okay? So when I say that P W y equal to 1, right, or word, or I'll say, let's say P1 of 1 is that word 1 and label 1, right? Or okay, maybe this is for word, label, sorry, this label.
In the top the superscript is the label.
Label, and subscript is the word. Okay, so
Word.
P10 is this one, right?
Non-spam.
Fine, right? Okay. Now let us try to understand this part now. I hope this is understandable. So
Mhm.
for this to understand, or uh, now I need to what? I need to find out only this one, right? Do I need to find out this parameter estimator? No, right? One is enough, right? Here, one is enough. So if I have three words, how many parameter estimators I need? Three
3.
for spam side,
And
and
3 from non-spam cells.
three for non-spam, right? So
Mhm.
total parameter I need is how many? Three plus
6 only.
Okay.
and one for this, right?
One
Label.
for level. One for level. Oh,
Oh,
mm.
is that okay?
Yeah. 2D plus 1.
Yeah. So the picture which is drawn in the lecture is this, right? So P is for label. Whether that label is equal to spam, then I have W1, W2, and W3, three words, right?
Yeah.
And these coins will have uh, the parameters, right? Again, this is, let's say, P hat is the for label, or estimator for that label. Here it will be P1,
1, P2, P3.
P2 1, P3 1. Similarly,
P11, P12, P13, and this is P01,
P1
P02, P03.
P20 and P30, right? This is W1, this W2, and this W3, right? Okay, so how many parameters I need to find out here? Let's say if you have D features like this, D. So how many features? So how many parameters this side? D parameters? Hmm?
Yes, sir.
Yes, sir.
Here non-spam side, D parameters, and plus one this side. So how many parameters?
Plus
Total
1.
number of parameters?
2D plus 1.
2D plus one. And previously, how many we needed to do that?
2 to the
Many,
power.
many.
So now we have
2 to the power.
significantly reduced it, right? So 2 to the
Pardon?
power, we have reduced the number of parameters, right, to be estimated.
Number of parameters. Yeah.
So now it is 2D plus 1. Previously it was 2 to the power D plus 1
D
minus 1,
plus 1 minus 1.
right? So if you have 5 features, so if you have D equals to 5, how many parameters we needed? If I go by this approach, how many parameters I need to estimate is 11, right?
1.
11 is 131.
And here it is
5. 5.
5 plus 1, 6.
6.
So 2 to the power
6.
6 is how much?
63.
263.
Huh?
63.
2 into 2, 4. 4 into
Oh,
2 is
yeah.
8 into 2
63.
is 16.
63.
16 into 2 is 32 into 2, 64. And 64 minus 1 is
63. 63.
so we have significantly reduced it, right? So as the number of features, right, the D grows larger. So D is what actually here in this case, let's say the dictionary,
No.
right? The size of,
Dictionary.
if the size of the dictionary is very large, right,
Hmm.
it goes larger. in that case, the number of parameters will be significantly lesser to estimate in case of this, right? If I treat each of this word as independent features,
independent features.
right? Now I'm considering these words as features instead of previously what I used to consider features as entire sentence, right?
Mhm.
I hope now you understand the difference. Previously, we considered this x1 as what? That entire,
Sentence, the whole three sentence at a time.
yeah. This one was one feature. This was or feature, or
Yeah.
let's say we were actually considering that x1 exactly. Now we are considering only the words. That is the difference.
Words.
Yeah. Is that okay?
Yeah.
Yes, sir.
Okay. Just give me a minute. I'll just plug in the charger and also I'll have water and come back.
Okay.
Okay. Yeah. Okay. Are we fine till now? Till this part?
Yes, sir.
Okay, with the generative story, what I said is we need to, what is the first step in the generative modeling? Find out the probability of label, right? So step one was what? Find the probability that y equals to 1. And let's say this is the, and what does that mean in general again? Is like finding out the estimate, right? For that parameter. Because we assume that it is a distribution and this data is actually coming from some distribution, and then we are able to uh, find it out, right? What is the next thing? Okay, what is the step two?
Joint distribution.
Yeah, so joint distribution, but we said no. What is the joint distribution here?
Probability of word.
Y equal to 1. Let's say y equal to 1, or let me
Probability of a word falling into
into probability of x given
X given
y,
Y.
X
right?
X given Y.
Now I know this one. In the first step, I found out this. What is
Or
the
we can take probability of X into probability of Y given X, right?
right? That
Both.
is,
eh,
and correct. And x contains, let's say, 3 features or d features. f1. We said 3 words, no? So consider
Yeah.
each of them, each of the word as a feature. So let's
Feature.
say if you have d features, so what does that mean? Provided that x equal to f1, f2 till fd, right? Given y. That is, I wanted to find it out, right? Okay. Now assume that. So here we are actually assuming that class conditional independence. What does that mean again? Have you seen the IID examples? Independent and identically distributed. In that case, or okay, in general case also, class conditional independence. What does that give me? It can I write it like this? Uh, Probability of
Probability of one
f1
feature is
f1
completely.
given y into probability of f2 given
F2.
y,
Yes.
probability of f3 given y, like that, up to probability of fd given y, right?
Yeah.
Okay. What will be the probability of f1 given y? Okay, how should I write down?
You did it because it F1, F2 are independent, right?
We are assuming that. So there is an
Yeah.
assumption here. The assumption is class conditional independence. This
Class condition. Yeah. What is this exactly in the lecture also?
conditional independence. What are we saying is, uh, these features, right? They are independent. Uh,
That I know. That I know. Why this word class conditional independent term were used?
because they are
Especially.
independent. Okay, first of all, conditional independence means given this is a conditional density, right? Anyway,
Yeah.
so this basically is what, like, can I say that this probability that f1 given y equal to 0, this is different, and there is another probability of f1 given y equal to 1. Is that fine? And there is another feature, let's say probability of f2 given y equal to 0 and probability of f2 given y equal to 1. This probability and this probability is same or different?
Different.
Different. And what about this one and this one?
All are different. Yeah.
Different, right? All four are different. So
Hmm.
if I say that given this class y equal to 0, right? If
Hmm.
f1 is f1 and f2, these f features are independent of each other given this class, and f1 and f2 are independent given this class.
Hmm.
Whatever we are saying that so this is a class, right? Y equal to
Hmm.
1 is a class and y equal to 0 is a class.
Hmm.
So conditional, so these features are conditioned on on the basis of a class, right?
Can we say that the independency of these
Feature.
variables are based on this class,
Yes.
right?
Even
Is it?
even the class is there. See, this is conditioned on some class, right?
Hmm.
Given that condition on that class, what I'm saying is that these features are independent of each other.
Pardon, once again.
Okay, so let us
No,
see.
what a statement you told, just one
This
in a
this is
statement.
the simple thing. See, let's say I'm saying that f1 given y, right? It is independent of f2 given y.
Yeah, that I got.
Okay, and this is a class, right? Y
Yeah,
equal to 0 is one class and y equal to
yeah.
is one class, right?
One.
So for this class, these features are independent.
Okay, got it.
Conditional
Okay, got it.
this
The
class.
class, the class
Class,
based on the class, it is
that
independent.
is why it is a class
Yeah,
conditional independence.
yeah.
Fine.
Hmm.
Okay. And let us say, for class given the class as y equal to 1, suppose, right? Y equal to 1. What will be this? How does this will look like? Can I say that it will look like this probability of f1 given y equal to 1
My one
into probability of
probability of
f2
f2
given
given
y
y is equal to 1.
like that, right? And so
Same
it is a product, right? So can I
product
say
of
that
the
it is a product of what? I equal to 1 to d, right?
to
Product
be
of fi,
fi given y is equal to 1.
let's say, right? Is that
Hmm.
okay?
Hmm.
But what is this probability of fi given y equal to 1? Okay, how should I write this down? So all these features, f1,
Yeah,
f2,
yeah, yeah.
f3,
Yeah, yeah.
f1,
Probability of y is equal to 1 into probability of y is equal to 1 into probability of
okay,
fi.
don't worry. Okay, I'll tell you what is it. So each of f1, fi, right here, it will take which values? Either 0
0
and 1, right?
and 1, yes.
Right. So all f1 to fd, they are all Bernoulli distributions.
Yeah.
So uh, this this product will be what is exactly equal to. Uh, can I say that what? So that many features, if it will be positive. So is it look like, let's say if you have 0, 1, 1, 0 and 1, right? Right. In that case, and suppose they are independent of each other. So what I'm saying is, you have a coin, okay? You have a coin
Yes.
with probability p, fine, okay? And I have tossed it for 5 times. What is the likelihood of this coin? How do you write down that likelihood? Generally, it is like p to the power 3 and 1 minus p to the power 2, right? In this case.
Yeah, in this case, yeah.
So let's say
3, three is the success, 2 is the failure, right?
this is f1, f2, f3, f5.
Hmm.
This p is on when
It will spam.
F2, F3, and F5.
f2, f3 and f5, right?
Yes.
So that means, can I write this product, above product, as p I, right, to the power f5?
Probability of I.
Yes, sir.
What actually, it's not like to the power f5. It is
And
kind of saying that if that feature comes there, right, it will be the probability of pi that corresponding to that feature. Is that okay? Or
Yeah, yeah.
it's kind
Got
of
it.
that, right? Okay. And now,
Probability of that feature is there.
and
Right.
again, one more thing I need to write down is here is 1. Is that okay? What is that 1 for?
1 is for given condition, right?
class.
So
This
Class.
is the
I have
class.
told you that this thing, right? The subscript will be the class or the label.
Class. Yeah.
So and sorry, subscript will be this. Superscript will be class or label,
Class
and
and
the subscript will be that feature or
the
word.
feature. Yeah.
If you remember that. Now,
Mhm.
understanding that, we'll try to get all the notations here, and the notations will be, this is going to be product of I equals to 1 to d, right? Pi of 1, or now if I wanted it to make generalized, it will be what? Y,
Y.
right? Into 1
Fi.
minus pi
Speed.
y.
Y. 1 minus Fi.
1 minus Fi.
Okay, just give me a minute. Huh? I'll come. I have one call to attend. Just give me 2 minutes.
Okay. Okay.
Right? Is that okay?
Yeah.
I hope this is fine. But now the question remains is how to find out these probabilities, right? We just have this formulated all of that, but we don't have any idea about all of them, right? We don't have this. What is it? Your p. This I need to find it out. Again, what I need to find it out? All of them, right? So basically, this is like pi of y equal to, okay, maybe I'll write it down like this. These many parameters, right? I equal to 1 to d. So how many parameters? Basically d
D.
parameters
D parameters.
in the spam side, and pi 0. So this D parameters, this D
And
parameters,
D plus
and
1 for label.
this
2D
for,
plus 1.
correct? Correct. But we have already seen how to find out these parameters or how to estimate these parameters, and that was what technique we have used previously. The maximum likelihood,
Likelihood.
right? All of you are okay with that part also?
Yes.
Mhm.
Hmm?
Yes, yes.
So can I say that? Can I say that we can find out the parameters by using the maximum likelihood, right? So this was our
For all the, for
for
2D plus
every,
1 for
yeah,
all.
yes. So here we have P, right? One coin there, correct?
Yeah.
It will say that label equal to 1. This will say that label equal to 0. Then here each of this D features will have what? D parameters. How will I write down here? P11,
P11, P12,
P21,
P13.
P1.
3.
Before, and here it is P1.
What should we call? First superscript or
Whatever
subscript?
you understand, or you
No,
remember.
let it.
No, how you wanted to remember, you remember it. But you have to remember it accurately.
Okay.
So
E0D.
yeah, it is totally dependent on how you remember. It's not.
So much notations are there. Yeah.
Yeah, that's what I tried to slow it down because it's like,
No, yeah, of course you are doing well because
okay,
in the lecture it is not becoming so much clear.
no, it's like so much of information is there in 2 hours, right?
Yeah,
So
so much it is being perplexed.
right. So yeah, and I think one of the thing we have and learned through examples, right, today, is that how to find out those estimates.
Examples are clear. Yeah, that's
So
why we are able to understand.
no, I am saying that how to find out these estimates. Uh, I was told you that there are, let's say, if you have 10,000 emails, and out of which 4,000 emails are marked as spam and
Spam.
6,000 are non-spam, and let's say P hat is the probability of success or that parameter for, let's say, that mail is what?
Spam.
Spam. Then in that case, what is this estimator there? 4,000 divided by 10,000, you said, right? Or
Yeah.
right? And how do you calculate that? You just have added all the labels, right? 1 1 1 1
All-
and plus
Yeah.
0 0 0 and divided by
Yeah.
10,000, right?
10th. Yeah.
That is what the same estimator you get from maximum likelihood. So it's already been there. So from maximum likelihood method, right? So how many parameters we need here? It's P here, D here, and D here, right? Or 1 here, right? So
2D plus 1.
yeah, so for this P, whether that is spam or non-spam, right? This is for label. Parameter for label, that is
11.
equal to 1 upon n summation of I equal to 1 to n. N is what? Number of examples,
Data
right?
point.
I.
Data points.
Right? Okay. That is like number of spam emails in the data set. Fine. Is that okay? That is my
N,
estimate there.
N is the
Yes.
number of spam emails, right?
No, total number of emails. N is
Total number of, yeah.
total number of
Total number of
emails.
emails.
And
And why I is that?
yi is what?
Spam.
Yeah. So if I say that we are counting all the spam emails and we are finding out uh, the fraction of spam emails. Okay.
Mhm.
Okay. Now what else I need to find it out here? The estimator for spam side and non-spam side. Is that okay?
Non-spam side.
Both, right? PJY.
Both.
So
EYJ.
so this y, right? This superscript, if it is equal to 0 and if it is equal to 1, right?
Yeah.
And j will go from where to where?
J will go from 1 to N.
N or D?
D.
D.
D,
Number
right?
of features.
Number
Yeah.
of features, right? So for all D, And y will take which values?
0, 1.
0 and 1.
Right, so it will take 0 and 1, right?
So value will be
Okay. So
y0,
yeah,
py, pj, and
So J is what?
words, right, or features, number of
Okay.
features,
number
right?
features.
That's subscript I told you, right? Here,
p0j and p1j.
right? Here 1, 2 to D, right? That subscript is for the number of features, right?
So we can remember like this now, p0d and p1d, right?
Yeah, I'm not telling you how, you will have to remember yourself. That's what. See, if I tell you something, I don't know whether it will be
Okay, okay, got
remembered.
it. Okay,
It's
fine.
better
Okay, fine. Yeah, now
you
it is okay.
understand and you try to learn it. I think that is.
No, okay, fine.
So what will be,
p0d, p.
yeah, so let us say I need to find out p11 hat. What does that mean?
It means that
One feature
one,
belongs to
For,
one.
yeah,
y is equal to 1 and d is equal to 1.
yeah, that feature, the for the first feature,
First
uh,
feature.
and then what will be the estimate there? So the maximum likelihood
1 by
estimator
n.
is basically is okay. It will look like this. I'll tell you how it will be and how it is calculated. Also, I'll tell you. Yeah, I think all of you remember. I think aware of this indicator function,
Indicator function, yes, yes.
right? So that
Yeah, yeah.
indicator function for what does it do? Whether if it is when it is true, it will
Yeah,
give
when
you,
the function is true, then it is 1. If it
and if
false,
it is
then it is 0.
true, okay. So fj of I. Okay, I'll tell you about what are these notations, and maybe we'll try to understand from there. So yi equal to y, and then divided by summation of I equal to 1 to n, the indicator function here, yi equal to y. What is the meaning of this?
Count of spam or not spam.
Joint.
So what? Let's say y equal to 0. If yi equal to 0, right? Okay,
Yeah.
and y equal to 0 means what?
It
It has,
belong to class 0.
yeah, or non-spam email, for example, right?
Non-spamming.
And if the email is non-spam, right? In that case, this feature, right? And j is for what? J goes from 1 to D, right? And
1 to d.
I will go from 1 to n,
1 to n.
right?
For each and every data point, it is calculating the j value, right?
So what we are saying is, okay, I'll give you the some simple small example,
Yeah, example.
right? And then we'll try to understand that. Suppose I'll say, uh, I'll give you this, like I will not write the words. I'll write instead of that F1, F2, F3 like that. Sorry, F1, right?
Mm-hmm.
So suppose this is my feature F1. Okay, there is this example X1. Okay, F, and there is this label corresponding to this X1. Fine.
Mm-hmm.
Is that okay?
Yeah, yeah.
Let us say I will use the two or maybe three features.
3 and y belongs to 0 and 1 only.
Okay, so let us say, oh, I think we can take that other example of that words, right? I think that will be better.
Yeah, the same example we can take here also.
So x1 is, let's say, it can take value 0, 0, 0,
0, 0, 0.
1. I'll write down the labels later, but first of all, I'll write it down like all of this values. 0, 0, 1, 0, 1, 0. X4 is 0, 1,
0,
1.
1, 1.
X5 is 1,
1,
0, 0.
0, 0.
X6 is,
So means जो features which are matching to the predicted value y,
correct, correct,
then we have to consider that number of count and then we find the probability, right?
correct. So, and that is the estimator basically. That is the likelihood estimator it's turning out to be.
Okay.
Okay, I'll write it down. Like, okay, so suppose all of uh, I'm not taking that the same exact example. I'm just giving you some different one. Okay, so that I think that will be better to understand. That is a different example which we have seen, but suppose, okay, maybe I'll do one thing. Okay, so when I say that this fj equal to 1, right, and yi equals to y, yi equals to y, what does that mean? So what are these x1 to xz? These are 8 sentences, fine, or 8 examples. Here I equal to 1 to 8, okay, j equal to 1 to 3, right,
Yeah.
y is 0 1, is that fine?
Hmm.
Okay, now what I'm saying is uh, this indicator function, right? So I need to indicate this part. So when yi equal to, let's say, 1, what is f1 of 1, whether f1 of 1 or f1 of I, right? F1 of I, I'm just now thinking about this. I'll indicate 1 when I'll go through all the examples. So can I indicate 1 here when yi equals to 1, if I or f1 is equal to 1? No, right?
No, it is not there.
So what is the indicator variable for
It
this?
is false. 0.
0. What about this?
Y is equal to 0. It is also 0. It is 1. It is also 0.
This 0,
This is 1.
1. What about this?
This is 1. This is 1.
This
This
is
is
about
1. This is 1.
okay. I'll do one thing. I'll just put it out there.
0. And
This
then
0.
it is 0. Then it is 0.
Is that okay?
Yeah.
So what this giving to me? So let's say I wanted to estimate this p of j equal to 1 of y equal to I think we were
1.
showing 1, right? 1 is
Y is
equal to
equal
what?
to J is equal to 1. And
So how many indicators are here? 3.
3 indicators are there. The 3 by 8.
So 3 by 8 or divided by of 8 is what, like divided by is indicator of yi equals to y. So yi
Okay.
equal to 1. So when that indicator will turn, so indicator of yi equal to 1. So here is 1, 0, 1. So basically it is like how many times 1 occurs? And 1, 2, 3,
Got
4,
it. Got it.
5, 5
5.
times. So this
5.
probability of this is going to be
3
this,
by 5. Okay. Okay. Wow.
right?
Typical.
And now p j equals to 2 of y equal to 1. Can you tell me now from this example? P of j equal to 2, y equals to 1.
2. Y is equal to 1. So 0, 0, 0, 1. X4 is 1. No,
X4 is not 1.
no.
X4
No. X6 is 1. X6 is 1.
X3 is 1. X6 is 1.
X3, 3, 6, only 1. 2 by 5. 2 by 5.
2 by 5. Right? Now you
Mhm.
understand?
Correct. Yeah, yeah, correct.
Do you understand that? So, okay.
Sir, I just confused.
Hmm.
Can you tell me PJ superscript y is equals to 1? How you get that 5?
5 is, okay, 5 is what? 5 I said is this, right? Okay. So here it is fine, right? This 3 is okay.
Yes,
Numerator
sir.
part. What about the denominator part? It will draw an indicator 1 when yi equals to y. But
Y.
y takes only how many values?
It
2
takes
values.
0 and 1.
So now we are looking for y which is equal to
1.
1. So it will indicate 1 when each of that example, right? The,
Yes, sir. We will count only that value which
yeah,
having 1.
this is 1, 1,
Okay.
2, 3, 4, and 5. I'm not, that's what I said initially. This is not the same example which you have used previously.
Got it.
Joined
Got it.
probability by the total probability, right? It is right. Huh?
Yeah, or you can say that the number of times it is occurring.
Similar to misclassification.
Yeah,
Yeah, yeah.
it's
Similar to that, it
same.
has come in the statistics like that.
Yeah, it is
Yeah.
same as that of that, right?
Mhm.
I hope this is okay. So can I tell you once more how to find out its estimators?
Yes,
I'll
sir.
write down once more, like P hat will be what then? Summation of I equal to
1 to D n,
1
sorry,
to n, 1 to n,
I
yi,
and P
this is 1 by n,
y hat.
jy hat is equal to
So we are summing over all the examples.
summation I to n,
Indicator of
indicator of
fj
fj
for each example.
for each I is equal to 1, and y is equal
yi
to
is equals to y.
yi is equal to y.
Divided by indicator of
Indicator of
Summation.
summation of indicator,
summation over all the examples,
all n y is equal to y.
Right.
yi is equal to y.
and I will be 1 to n, j will be 1 to d,
1 to D.
and yi will take values.
0, 1.
Done.
Yes,
Hmm.
sir.
Okay, now this is fine. Okay, this is what, like, okay, these are the parameters we have found out, right,
Mhm.
from the maximum likelihood estimate. But now this is what happened during our training part, right, based on the data. Is that okay?
Yes,
Hmm.
sir.
Now I need to predict also, right? If any new data points come in, I need to find out its label, correct? So what is the next task? If any X test comes, right, I need to find its
Y level,
Y test, right? Y hat test, correct?
y hat test.
And this X test also belongs to what? 0, 1, D.
0, 1,
That is okay,
yes.
right? It
Yeah.
will have the D features again, that anywhere, because we are saying that the length of that vector, right? It has to be D,
Yeah,
and each of that one to D, it can take two values, either 0 or
each feature can have the two values only,
yeah,
right?
yes, you can say in that way. Fine,
Hmm.
right? Okay, but how do you do that now? What I'll do is that I will find out probability of Y test. Okay, I think this is okay. I'll write down. Okay, doesn't matter. Okay, I'll write down. Maybe what I'll do is whatever the notation sir has used, I'll use those. Okay. It's fine, right? Test point is okay, right? I think test point.
Yes, sir.
I
Can you once show again for the previous formula what we did? Just
which one?
previous one. Yeah. Okay. Thank you.
Okay.
Thank you.
So now here, I need to find out probability of Y test, right? Either it can be one. Okay, Y again. The test prediction also will have only two classes, right? Here, in this case,
Mhm.
given X test,
X test.
right? And we have to find out probability of Y test equal
Y
to 0
test
given
is
X test,
equal
right?
to 0.
Right. Okay, and we'll have to check whether this is greater or not. If this is greater, then what will be my label?
1.
1.
If if this is true, then Y test will be 1, and otherwise it is 0. Is that okay?
This is the estimate
Testing part, or the prediction
test
part. Test or prediction,
prediction part.
right?
Mhm.
Whatever we have found out previously, this is during the training, right?
Right.
So based on whatever the data and the labels are given to me, or data points and the corresponding labels are given to me, I have found out the estimators, right? For P hat and Pj hat Y, like 2D plus 1 estimators we have found out, and based on that, we wanted to predict. But
So whatever the points are given in the class Y,
hmm,
we have to calculate each and every point, and then we have to compare it with
yes,
the class 0.
right.
Okay.
Yes, right. That's true.
So,
But
sir, how we do that?
yeah, so okay, I'll tell you. So I need to find out this part, right? This two. Okay.
Mhm.
But
Yes, sir.
okay, how to do that?
Based on the value of this, we will decide whether y test will go, right?
Correct. So anyway, we need to find out this part, right? That is true.
Mhm.
I hope all
Yes,
of
sir.
you understood that part, right? Now, but I
Yes, sir.
don't know how to find out. So this probabilities I need to find out, but I don't know how to find it out. But do I know the Bayes rule? Yes, right.
Yes, sir.
So
Probability of
what is the Bayes rule for this? If I apply Bayes rule here, can I say that probability of y test given x test, probability of y test
probability of
so it will be what?
probability of x test
Test given y
given
test equal to
of
what?
y test is equal to 1 into probability of
Y test
y test.
equal to 1, right? And
Yeah,
divided by
divided
Probability of X test.
x test.
what about this side, left hand side or right hand side? It is probability of x test
X
given
test
y test equal to 0
y test equal 0
into
into probability of
probability of y test equal to 0
0
probability of
Y
x
test.
test.
x test.
Sorry, X test.
Sorry, not x, so x test.
Only x test.
Yeah, right. Is it fine? And I
Mm.
need to compare these two values. But when you do the comparison, this probability and this probability will be the same, right? Because that data point is the same, correct?
Only our numerator is
Yes,
required
sir.
to be.
So whenever I wanted to compare the values, I need to compare only this and this.
Hmm.
Is that okay? Hmm?
So, but value will be changed now if we consider probability X test both are same,
Ah.
but when we divide the whole, it will
No,
get
numerator. See, numerator. Let's say the numerator x test is equal to, let's say, 10. Okay, or okay. Let's say we are actually talking about probability. So probability can, let's say probability is 0.5. Probability of x test is 0.5.
hmm,
Here also it will be 0.5 in the denominator.
yes, sir.
Let us say
What
above
is
probability is 0.3, and here it is 0.2, which is greater.
just comparison?
So do I need to
No,
divide
no, no. Only numerator part.
correct, right?
Only numerator will work. No problem.
Got it.
Got it. Okay, so that means I need, if I find out numerator probabilities, that is okay, right? Right?
Mhm.
So if we divide that, then also it will be like
Yeah. So what is the division here? Let's say 3 by 5 is 0.06, right?
yes, sir.
And here it is 0.04.
Hmm.
So which is greater again?
Yeah, got it.
Got
It's
it.
going to be right. It's like if the denominator is same, you don't need to worry about when you do the comparison.
Yeah, yeah.
It's like it will not be changing anyway. Fine. So what I need to find out, I need to find out two probabilities. Now let's say what was the one of the numerator was this, right? X test given y test equal to
Test equal 1.
1
One.
into probability of y test equal
I
to 1.
test that's one.
But I told you, right? X test will contain what features? How many features?
One FD
Features, and each of fi belongs to 0.
belongs to 0 and 1.
Hmm. Can I say that it is P of f1, f2, fd, right? Given y test equal to 1 into probability of y test equal to 1. Is that okay?
Yeah, right.
Yes,
Test
sir.
And if I use the class conditional independence, what will be the value here?
Probability
Can I say
F1
it's product,
given
product of I equal to
product of
1 into D,
hmm,
then
probability
Pj
of
hat
D F
1
1
power fi
Fi
1 minus Pj.
so we considering it as I now.
What is it?
I PI.
1 minus Fi
Okay, okay.
One thing,
1 minus Fi.
I think I should write down. not I, it is J.
Yes,
Yeah,
sir.
it is J. It's J.
Is that okay? This is fine, right?
Yes, sir.
I hope no issues are there. And into what is this probability? It's like p hat, right? Corresponding to that one. Do I have the estimator for this? Pj hat all for D, all D's.
Yes, sir. 1 upon n summation of.
That indicator we have seen, right? And
Hmm.
we have this also. So can I be
11.
able to find out this probability?
Yes, sir.
Now what we need to compare again? The comparison was with this, right? Probability of x test given y test equal to 0 into probability of y test equal to 0, right? What is this probability? It is probability of I, sorry, a probability of I equals to 1 to D. Again, I'll write down the same thing right here. Do I need to write it down? Okay, I'll write it
No,
down.
No,
sir.
No,
no, no.
if I can directly write down product is fine.
Hmm.
Yes,
Same
sir.
thing, only here it will be 0, and that product will be what? Product of I equal to 1 to D,
1 to B,
J,
J 0,
0, right? To the power
F, Fi,
Fi, Fj,
Fj,
and 1 minus Pj
J 0,
to the power
1 minus Fj.
J. And what about this? It's 1 minus P hat.
This is 1 minus P hat.
I
Hmm.
hope it is fine.
Hmm.
Huh? Now, now I have found out this value, I have found out this value, and now I'll compare, right? If this is greater, this probability is greater than this, what will be the prediction for
This
x
will go
test?
to the 1. Spam,
Level,
spam.
level 1, right?
Level 1 is spam.
And if this value is lesser than this value, then the
Then,
label will be,
yeah, level will be 0.
is that okay now? Is that fine?
I think it is the whole formula. It will be better to calculate if the numerical data are the given or something like given in
Ah,
the table,
yeah,
in the table form, no?
yeah. But in general, see, we don't do it manually, right? Like the computer, like if the data
Okay.
set is very
Then
large,
question. What type of question
questions,
will be
it will be
framed
like
like?
if you have the data like this, you'll have to find
Mhm.
out from the, like I just showed you, right, how to calculate. We have seen
But
one example.
two or three data will be given, no? D, like that.
Yeah, like I'll tell you, like where it was there. I think we have seen
Yeah,
one.
we calculated it. Same type of questions will be
Yeah,
like
yeah,
that.
yes.
Then in such questions,
Like this.
it will be easier to calculate by the table type, right?
Right. So we have seen this, na? This
Mhm.
we have
Yeah.
3 by 5 we will calculated. Now I'll give
Mhm.
you x test as, suppose I don't know, 1, 1, and 0, right? Can you
Mhm.
calculate now? Uh, yeah. So you will have this thing with you. Similarly, you will do it for j equal to 2, j equal to 3, right? You have 3 for y equals to 1, right? And then you calculate. You understand the part? The
Mhm.
calculations are
We
like,
will calculate it. One, two questions we will do it, you know, then
yeah,
you can be clear.
yeah. It is. So you can actually see one of the previous term questions.
Yeah,
It
yeah.
is there, and if you try to solve that, it will be like,
Solutions are also there in the.
I don't know. You have to.
Okay.
It will be available somewhere. Somebody has
Yeah.
done that.
Okay. Okay. Okay.
So anyway, if you're not able to, I'll solve it later. Okay. So what we have done here, can we do it once more? Uh, Probability of
So today
y
Y test
given
X
test,
test.
uh, and
Mm,
and it will contain these features.
mhm,
Hmm?
mhm.
And
Okay.
we compared it with, or
Yeah.
okay, or let's say what was that, what was the value for that product of I equals to 1 to D, right? P,
Mhm.
or let's say J,
P J
Pj hat, let's
at
say y
Y
test equals to, let's say 1
Y test equal 1, the 1
to the power
to the power Fj
Fj, right, into 1
into
minus
1 minus P
J
J to the power 1 minus Fj
into
P
into
cap.
P hat.
P hat.
Right? So this is the product, right? Do you understand this is a product?
Yes, sir.
Right.
Yeah.
So initially I said that we have three words, W1, W2, W3, right? Or let's say F1, F2, F2, F3. These were the three words. We said in our dictionary we have only three words. Fine. And how we have said that? Let's say you have seen 1,000 emails, and what you do is you find out its unique words and added them into the dictionary, right?
10,000 suppose.
Correct. Now let's say those words are three in that your dictionary, and from that what you calculated is p hats, right? Like all the parameter estimators you have found out by using the data. So that has happened during training. But in the test, it is not necessary that only these three words will be there. Maybe one more word has appeared. But
Yeah, it is
uh,
new word.
right. So you had the estimators for this, right? Let's say P11 had P uh, 21 had
2 1 hat,
P3
P3 1 hat.
had, and P0 sorry P1 0 had P2 0
Hat,
had, and
P2 0 hat, P3.
right, we have the estimators for that. Also we have the estimator for this.
P hat has.
But now if your test data point contains these words, let's say your test data point is containing this, F4 is some other word which was you didn't see during training. What will be the estimator for this word now? So P4 one hat, the estimator will be what?
0.
0, right? And P4 uh, 0 hat, what will be the estimator for this?
0.
0. Why? Because these estimators are what? Like it should appear into that, right? That indicator we said, no? That has to be appeared in that spam or non-spam thing. If it is not appearing, it will act as a 0, right? Then
Mm-hmm.
then the probability is what will happen to this probability. Let's say for one class, it's a product, right?
Yeah, it is 0.
It will become 0, right? And similarly in non-spam case,
If
it
it
will
is 0, then it will go to the non-spam, no?
no the product, this value will become product. No, we have to compare, na. Actually we see, I said to you, we
Correct, correct.
were doing this, no, this part we
Yeah.
are calculating this separately, this product, and we are calculating this product separately. But for both of them,
We have to
the
compare.
estimator for that new variable is coming out to be 0, right?
Hmm.
Now both side it is like kind of 0 0, right? This is 0 and this is 0. What should I compare? Can I give any label to it? No, right?
No.
So
No.
now that is a problem, correct? That is a problem. So
Yeah.
what should we do in that case? Instead of so if you said something like this, or because see, as a human you understand it, but as a machine, the computer has to understand that, right? We'll have to set some rules for that. And what we can say is that if you don't find any word, uh, like let's
In the
say
dictionary. In
in
the
the
dictionary.
test, yeah, so if in the dictionary you shouldn't say that the estimator associated with that estimator is basically for what, like probability only, right? Correct,
Hmm.
right? So you're saying that don't assign it to be 0. Instead of, what do you do? Assign it to some low quantity, right? Let's say 0.001 or 0. Like
The lowest
0,
quantity.
but it shouldn't be a 0. Fine. Okay.
Hmm. Hmm.
Now is it possible for you to compare these two things, spam and non-spam? Right, because okay, I'll tell you how. So suppose if this word was not there, in that case the probability was coming out to be 0.3 for spam thing, right?
Hmm.
And for non-spam thing it is coming out to be 0.4, right?
Hmm.
Only considering features f1, f2, f3. Now if I wanted to multiply with the this p4 hat, So suppose this is 0.0001, and same it will be like 0, and you will have to make it same. Okay, both the sides. That also is there. If that word is not there, right, in both spam side and non-spam side, the probability associated with that you will have to make it same. You are understanding my point?
Yeah, yeah.
What are you achieving this from this? Now you are able to compare, right? It is not
Yeah.
becoming when it was 0, this and this product was
It was not.
actually
It
becoming
was
1,
not. It was not able to compare.
right?
But
So,
now,
yeah, but now with this simple thing, this assigning some small probability to that extra new,
anonymously, we will assign the value anonymously. Huh?
yes, like you tell that in prior. So whenever any new word will come in, right? If
Okay.
you if you think any new word is there, it's not in your dictionary, assign that word as a some probability value. Fine. Make this as a pseudo word, okay, or pseudo feature, and assign it some probability to that. Is that okay?
Yes. Yes.
And that way you will be able to give the decision, right? And this technique is called as the Laplace smoothing.
Laplace's
Laplace smoothing. Laplace smoothing. Laplace smoothing or Laplace smoothing.
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 S double O.
Yeah. SM double O. Okay.
Okay.
SMOOTHING.
Smoothing. Yes. The smoothing of that data.
Okay. Understand, right? So if any new word is there during your test time, you should you shouldn't assign it the probability 0 to it. You should assign some probability to it. Okay. Or you create a dictionary such that any new word will come in, it will have some kind of probability associated with that. So that what will happen is it will that will not 0. So what was the decision function for the naive Bayes theorem? Hmm?
Yes.
What was it? Okay, I'll take your like maybe maximum 10 minutes and we'll stop there. The whatever remaining part is there, it will be covered on Monday during our solve with us session. But it's not like not much of the things are remaining. It's like only one more thing, but that you will get it later. Once you understand this, that is not a difficult part. So for
Probability of xy is equals to probability of x given y.
yeah, so we are saying that for any x test, probability of y test equal to 1 given the x test
X test is
uh,
equals to
should be or we'll have to check for probability of y test equal to 0 given x test, right? Is that okay? That is what you wanted to compare, right?
yes.
Okay. So what I'm saying is I'll divide it by this quantity. Probability of y test equal to 0. Sorry, write it properly. I'm just saying that it is probability of y test equal to 0 given the x test, right? I'm writing this decision function in a different way. If it is greater than or equal to 1, what should I predict? The prediction will be,
Y test is equal to 1.
It belongs
yeah, y equal to
Y
1.
equal to 1.
And if not, then y equal to
Or
0.
to
0.
0.
Is that okay now?
Yeah.
Is this same thing? Do you feel that it's the same thing as we did it previously?
Yeah, the same thing written in the fractions.
Is that okay?
Written in the fraction, right?
Right. Okay, fine. So what is this part? The numerator part? It is like this probability of sorry, I this was this, right? X test given y test equal to 1 into probability of
X
y
test.
test y
Y
test
test. Y test.
y test equal to 1. This is the base theorem, right? Base rule.
No, no. Base Y test.
1 given that, oh sorry, not given, divided by
No, divided by
probability of x test, right?
probability of X test.
And now whole divided by that is
2.
the same. I'm not doing anything
whole divided by, okay, ratio.
This
X test y test is equal to 0, probability of y test is equal to 0, probability of X test.
I hope all of you understand this part. That is greater than equal to 1.
Yes.
In this case, what will happen? This will go to cancel because that is same, right? Anyway, we are doing the comparison. We said that point also that is not required anyway, and here also it is getting reduced. So what is this upper part here? It was product of I equal to 1 to d
N.
d, right?
Hmm.
Pi, I use j there, but let us say because I'm using I here, okay, let's say j equal to 1 to d, pj to the power or pj hat 1
Is hat 1 to the
fi
power fj,
fj
fj
1 minus
1
pj
minus pj
1
to
hat
the power
1
1
minus
minus
fj
fj
into p hat
e hat.
and divided by. So can I do the product common for all? Anyway, it will be for all d vectors only, right?
Hmm.
Hmm?
Yes, sir.
Right. So and that will be here what in the denominator. What is the product here? Pj hat, but here it is 0, right?
0.
The power fj into 1 minus
pj
pj 0 hat
0 hat
1 minus fj
fj
and
p hat
here not p hat. It will be 1 minus p hat.
1 minus p hat, correct, yes.
Right. Product of y test equal to 0 is 1 minus p hat. Is that fine?
Hmm.
That is greater than or equal to 1. Okay. Until this part, all of you are with me.
Yes.
Sir.
Now, what
Yes, sir.
I'll do is I will take log on both sides.
Yes.
Is that okay?
Yeah.
So log of 1 is
0.
0. So this entire term will be like this. No, can I just do it like this instead of writing whole terms? I'll write as 0. Is that okay?
Yeah. Correct.
Okay.
Okay. Now, if this log goes inside this product, what will happen to this product?
Submission.
Summation, right?
It's summation of
And then what will be the summation? Let's say the summation will be summation of
f fj
j equal to
1
1
to
to
d
d.
fj
Let's say can I say that I'll think of these two quantities now. This together, this ratio together, this ratio together, and that like all three ratios together. Is that okay?
yeah fj into
Tell me. It will be.
log
Can I say that it log of or okay fj outside
fj fj inside the bracket log of p
log of
hat 1j minus p hat 0j.
yeah. So it will be pj yeah at
1.
1 divided by pj
0.
0. Is that okay?
Yeah.
What about this product? With plus
1
plus
minus
1
1
minus
minus fj
1 minus fj.
right,
log.
and the entire thing is in the sum, right? That you I hope all of
Yeah.
you are fine with that part.
1 minus fj. 1 minus log of
Log.
1 minus p
Yeah, 1 minus
hat p
j
hat 1j.
upon 1 minus pj hat 0, right? This is okay.
Hmm. Hmm.
The last part will be plus log of
log of log of p hat by 1 minus p hat.
right, and it should be greater than or equal to
0.
0 0.
okay, fine. Do you remember the linear regression problem? It's- okay, but I hope you remember one thing in the linear regression problem, or in general, if you wanted to found a boundary, right? So can I say that, how do you, okay, how does the linear equation look like? W transpose X
X
test
W.
plus
test
B,
plus
right?
B is equal to 0.
0, that will be a line, right? What
That
I'm
will be
saying,
a line.
yeah, what I'm saying is, if, or prediction phase is predict y test equal to 1 if this line is greater than or equal to 0. Hmm?
Okay.
Right? And y test equal to 0 if
Less than 0.
W
W
transpose X test
B.
plus B less than 0. Okay?
Hmm.
But
Mhm.
that means I actually I wanted to see this equation, the above equation written in this format, right? Can you think of this part, this p hat by p 1 minus p hat? This will be one constant. Can this be a constant?
Yeah, constant.
Yes.
So let us see, this is a b. This is b.
Hmm.
Okay. Now, one more thing you'll have to see. Okay. How do you see that? Okay. Let me do one thing. What about this part? 1 minus.
Fj.
Okay. I think before that I do one thing. I'll can you are you, if I don't do that, can you tell me that is it possible that I can separate it out first of all? Okay, I'll do one thing. Can I separate out this part? Okay.
Fj we can separate out.
Yeah, I'll just expand it a little bit. I'm not doing anything different. I'm just saying that. Sorry, it's not log. The above function was summation of I equal to, or j equal to 1 to d.
D.
What was that? The first part was fi times log of this, right? Huh? So it is
Yeah.
fi of log of, what was that?
Pi
pj
1.
1 hat divided by pj 0 hat.
0 hat.
0.
Then plus what?
Plus.
Uh, so if I do that, it will be minus, right? Basically, minus of fj. See, this quantity will be this plus fj times this, right?
Yes, sir.
If you don't understand, let's say this is c, some constant. So 1 minus fj of c, how does it look like? C minus,
C minus C Fj.
right?
Okay.
Yes.
So this quantity I am writing it first. So what that will be then? That will be minus of something, right?
Minus log 1,
Minus f,
1
minus
plus
fj,
pj.
yeah, minus fj into log of this, right?
Hmm.
But if minus sign goes inside the log, what will happen? The numerator become denominator and denominator will become numerator.
Right.
Is it okay?
Yes, sir.
Yeah, I know this is like a bit, but just bear with me for a second. If it's easier, if you look at it, it's not that difficult. What will happen then here? Log of 1 minus
1
pj
minus p cap, pj 0.
and pj
Only p.
1 hat.
Mhm.
Pj.
Sorry, pj.
And what is remaining now? Plus
My
1 minus Fi.
this part.
Okay.
This part was there log, because I have, we have that part also, right? This constant
1
part.
minus pj 0.
Sorry, here it
No,
is
sir, 1.
1.
1 minus pj 1, 0.
Done. And plus the remaining part was what? Log
How
of,
did we? How did we? This second term came Fj log of 1j P
I
P
said.
hat 0.
So this was, I said, 1 minus fj was there
Yeah.
of this total term.
Uh,
And if I multiply
yes.
that, what I'll get?
C minus CFJ.
C
CFJ.
minus, let's say, fj into c. Is that fine?
Yeah.
And
Okay. Okay.
what was
Reversed.
log of that, right? And if that
Okay.
minus
Okay.
sign goes into that,
Okay. Got it. Got it. Okay. Reverse. Okay. Inverse. Yeah.
hmm,
Plus sign.
and entire thing is greater than equal to
0.
0.
0. So, and what do you say about these first two terms? This term
Terms.
and this term. Can I take fj common?
Yes.
Fj common you
Yes.
can take log
And
plus log
log plus log will be product.
product.
So can it be summation of I equal to or j equal to 1 to d fj
J
common
p hat ij
log of
p high what
p j1 hat
j1 hat
1 minus
1 minus pj. Yes,
and
pj j p hat 0 j 1 minus p hat 1 j. Right.
this is okay,
Yes. Yeah. Okay.
and plus this quantity. So now tell me, is this quantity a constant?
Last is constant. No?
This is constant.
Mm.
Is
Yes.
this also constant?
Yes,
Mm.
sir.
Why it is
Yes.
constant? Because all of these are the parameter estimates, right? And why this is not constant? Because it is depend on what?
Fi.
Fj
Fj, right? So that feature,
data.
if
Fj is a feature
yeah,
data point.
yeah, so that is a random variable kind, right?
Mm-hmm.
It is x kind of, right?
समझ
So now I'm saying that this green portion I'm writing it as b. Entire green portion is b, right? This is kind of x. Hmm? Hmm? And this is
W
kind of w.
transpose
W.
Yes, sir.
W
So
W
now,
transpose
yeah, now look this as kind of line w transpose x plus b,
B
and entire thing is what?
represent a line.
Yeah,
You
and it
say.
is when I say greater than or equal to 0, right? Hmm?
So how transpose like
Yeah, no, it's okay. I'm just saying that it is actually coming as transpose if you look at it, but or you can say that it's a product because it's a sum, right? Summation of this variable into some constant, right? This is a constant, right? Log of entire term is a constant.
yes, sir.
So if you think about this matrix, right? The summation of xi into wi is equal to w transpose x. If you remember from that vector,
Mm-hmm. Yes, sir.
yeah, right. Okay, so now how does it will look like? That is the question. So will this be a line then?
Yes, sir.
Okay, so the point I wanted to raise here is, let's say this is w, right? This is a w vector which is going through uh, origin, right? And the let's say there is one vector x, right, or one variable x. The product of that, so w transpose x will be 0, which is that line.
Passing through the origin.
Yeah, why? Because it should be perpendicular to.
Perpendicular, yeah, W transpose, yes. Orthogonal.
So this is, let's say, this should, okay, this should go through this, right? So this is w transpose x equal to 0. uh, Here what is this case? It is w transpose x plus b, right?
So it will be shifted through B.
It should
It
be
will
shifted,
per-
yeah, and it is
towards the direction of the W, right?
right.
Plus
So it is here. Will that be line w transpose x plus b or equal
B.
to b? Let's say
Yes, sir.
not equal to b, plus b equal to
Plus
0,
equal to 0.
right? So what we are saying is w transpose x greater than or equal to 0. I will predict it as 1, right? And for others, I'm predicting it as
0.
Okay.
so all this side it will be a
1.
1, and all this side it is 0.
0.
So what we are trying to say is that the decision boundary, right, for the naive base, is it what
Yes, sir.
is linear.
Hmm.
So the conclusion from the discussion is that the decision
It's linear.
boundary for naive base is linear. Is that okay?
Naive base, what does we mean by that?
Uh, so this is base theorem, right? We have applied base
Okay.
theorem.
Yeah, base theorem.
Yeah, and we have used one assumption here. And what was that assumption? Class conditional
Class
independence,
condition dependent, yeah.
Class condition independence.
right? So we are saying that based on the class, we are assuming that all the features
Are
are
independent.
independent of each other.
Okay, okay,
And that is the naive assumption. So
okay.
naive means like it's kind of what do you say? Very basic kind of
Yes,
assumption.
very basic kind of assumption.
Yeah, and that's why it is called as a naive Bayes classifier,
Okay, okay.
right? So that's why this algorithm which we are actually looking at it is a naive Bayes algorithm. Is that okay?
Yeah.
I hope till that part is no issues there. There is one more part is remaining, which is uh, again like if the features are so until now what we have considered the all the features we have considered xi is or 0 and 1, right? In data.
Mm-hmm. Mm-hmm.
That means we were considering only binary features, right?
Binary.
But in real world, will that be a scenario?
No.
No, right?
No, no,
No,
no,
sir.
no.
The features
Multi-dimensional.
or maybe yeah. So let's say if the features are if there are continuous features and if there are discrete features. So discrete features we can assume as a binary, right? Or yeah, more than that, but still it is possible. And continuous features we can since in a real life world, right? We consider them as they are coming from a Gaussian distribution, right? Now if you include those Gaussian distribution, what will happen to the parameters? That is the case. I will not touch upon that today. Maybe whatever uh, discussion happened today, right? You just watch the lectures, you will get it. Otherwise it will be discussed in Monday's session. Is that
This
okay?
content is in the lectures, no? In the week 8, no?
This is week 8. Yeah,
Okay.
only
The
that part
same
is remaining.
the same thing is a content is a derivation has been given in the lecture only, right?
Yeah, same thing,
Okay,
same.
okay, okay, fine. Now it will be clear in that.
Yeah,
Okay.
now you can whenever you look at it, maybe you will be able to relate it more.
Yeah. Of
So,
course. Most of
so
the thing we'll understood.
yeah, so check it first of all. Go through the videos, and then when you
Mm-hmm.
come to the Monday's class, right? Maybe so. I think Nikita will handle that. Probably you can just so that it is same. Whatever we have discussed for binary features, it is same. The only difference will be what the parameters will change, right? Till now,
Mm-hmm.
the parameters was what for each of that feature. The parameter was p1 one hat, right? And we were not calculating this part because if I calculate this, it is not required, right? But if the feature is normally distributed, what will happen to the parameters?
Mu and sigma.
Mu and sigma.
Mu and
Right?
sigma.
The variance matrix will be appearing, and then accordingly it will change. That's it. That is the difference.
The
Otherwise, there
mu will be right.
the number of parameters will increase, right?
Yeah,
That's
yeah,
what.
yeah.
And then you will have to find out their estimates. Estimates are also given to the lectures. If you don't understand, right, maybe you can come to
Okay.
the Monday's class, or whenever I'll take one of the revision sessions, I will clear that part with you. Fine. I think it's same. It's not like very difficult. If you understand this part, right, it is like almost the kind of same thing. Shall we stop now?
Yeah.
Okay.
Yes, sir.
Okay, sir. Too much.
Thank you, sir.
Yeah. So, yeah, that's why
Okay. Good.
I want to touch it like today. But you
Good
can.
night.
Yeah. Thank you guys. Thank you for
Okay. Thank you. Good night.
yeah. Good night.